Sudah, Mbak.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera untuk kita semua. Om Swastiastu, salam namo buddhaya, dan salam kebajikan. Semoga kita semua dalam keadaan sehat walafiat. Selamat datang dalam acara Kick-Off Dikti AI Center dan webinar Creating and Connecting Virtual Worlds Using NVIDIA Omniverse. Nah, sebuah kehormatan bagi saya untuk memandu acara pada siang hari ini, pada hari Selasa, 15 Maret 2022. Dan selamat siang saya ucapkan kepada Profesor Insinyur Nizam, selaku Pelaksana Tugas Direktur Jenderal Pendidikan Tinggi, Riset dan Teknologi. Selamat siang kepada Ibu Profesor Cici Sri Cahayandari, selaku Pelaksana Tugas Sekretaris Direktorat Jenderal Pendidikan Tinggi, Riset dan Teknologi. Mr. Ragu Ganti as a Regional Sales Leader for Provis and NVIDIA Enterprise Software, dan Ibu Lina Wirahadi selaku partner dan sekaligus moderator yang akan membantu saya pada hari ini. Ibu Lina merupakan perwakilan dari EPSINDO. Selamat datang dan salam hangat kepada seluruh partisipan yang telah hadir dalam acara siang hari ini. Dikti sebagai salah satu pusat unggulan kecerdasan artifisial atau kecerdasan buatan pada sektor pendidikan yang mewakili Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi, maka di Indonesia sendiri beberapa perguruan tinggi telah memiliki superkomputer, di mana masuk ke dalam peta aplikasi arah strategis pembangunan kecerdasan artifisial pada sektor pendidikan. Nah, selain itu, Dikti juga telah menyiapkan sebesar 25 petaflops sebagai bentuk dukungan dalam strategi nasional kecerdasan artifisial di Indonesia. Nah, dalam rangka mendorong pengembangan dan penelitian AI yang menggunakan superkomputer pada perguruan tinggi, Ditjen Dikti menghadirkan layanan berbagai sumber daya superkomputer yang bisa dimanfaatkan oleh perguruan tinggi. Sudah sebanyak 41 proposal telah mengajukan kerjasama dalam pemanfaatan fasilitas superkomputer Dikti AI Center, dan sebanyak 10 proposal use case terpilih dan akan mendapatkan pemanfaatan dan juga pendampingan Dikti AI Center. Untuk itu kita ingin mengenalkan 10 proposal use case terpilih, dan Dikti bekerja sama dengan NVIDIA dan juga PT EPSINDO menghadirkan Kick-Off Dikti AI Center dan webinar Creating Connecting Virtual World Using NVIDIA Omniverse. Baik, Bapak Ibu, untuk membuka agenda kita pada siang hari ini, marilah kita menyanyikan lagu Kebangsaan Indonesia Raya. Dipersilakan untuk sikap sempurna.
Bangsa
Beranjak ke sesi selanjutnya, marilah kita dengarkan bersama sambutan dan arahan yang akan disampaikan oleh Pelaksana Tugas Direktur Jenderal Pendidikan Tinggi, Riset dan Teknologi kepada Profesor Insinyur Nijam. Kami persilahkan.
Assalamualaikum warahmatullahi wabarakatuh. Semangat pagi, salam sehat, salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan. Rekan-rekan sivitas akademika yang saya cintai dan banggakan, puji syukur alhamdulillah pagi ini kita bisa menyelenggarakan kick-off Dikti AI Center untuk membangun kreasi dan menghubungkan dunia maya melalui platform NVIDIA Omniverse. Sejak tahun 2021 sebetulnya kita Dikti Ristek mendorong perguruan tinggi untuk mengembangkan kompetensi dan mengembangkan inovasi berdasarkan penelitian-penelitian, riset dan pengembangan di lingkungan perguruan tinggi yang berbasiskan pada teknologi artificial intelligence. Dan pada awal tahun 2022 ini, pada tanggal 3 Januari 2022, Kementerian Pendidikan Riset dan Teknologi, Direktorat Jenderal Pendidikan Tinggi Riset dan Teknologi telah meluncurkan satu fasilitas server komputasi dengan kemampuan tinggi 25 petaflop yang dapat dimanfaatkan secara terbuka oleh seluruh perguruan tinggi, seluruh insan dikti di Indonesia. Fasilitas superkomputer Dikti AI Center ini kita tujukan agar tercipta ekosistem serta talenta, pengembangan talenta AI, artificial intelligence atau kecerdasan artifisial di Indonesia melalui kolaborasi antara perguruan tinggi dengan seluruh mitra industri, baik melalui kegiatan-kegiatan pelatihan, pendidikan, maupun juga kerjasama riset. Dan yang sangat kita ingin garis bawahi adalah kolaborasi tersebut adalah kolaborasi yang melibatkan mitra industri. Melalui AI Center ini, kita berharap kemampuan perguruan tinggi kita di dalam memanfaatkan teknologi AI untuk menyelesaikan berbagai permasalahan di industri maupun di dunia kerja, di dunia kehidupan, itu bisa meningkat melalui kerjasama yang erat antara kampus dengan seluruh mitranya. Dengan spirit Merdeka Belajar, Kampus Merdeka, fasilitas ini kita harapkan bisa menjadi bagian untuk mengakselerasi kolaborasi antara kampus dengan dunia usaha, dunia industri, dan menghasilkan inovasi-inovasi AI, kecerdasan artifisial, yang menjawab kebutuhan industri dan lembaga pemerintah ke depannya. Pada batch ini, kita telah menerima 41 proposal untuk kerjasama dalam pemanfaatan fasilitas superkomputer Dikti AI Center, dan 10 proposal use case telah terpilih untuk mendapatkan pendanaan dan pemanfaatan dari Dikti AI Center. Selain itu, melalui platform Kerdereka Matching Fund, kita mengundang perguruan tinggi untuk bekerja sama dengan mitra, industri, pemerintahan, dan berbagai stakeholders lainnya, pemangku kepentingan yang lain, untuk mengembangkan berbagai aplikasi AI dan bisa memanfaatkan AI Center yang ada di Direktorat Jenderal Pendidikan Tinggi, Riset dan Teknologi. Pada para peserta yang telah terseleksi untuk pengembangan 10 use case tahap pertama ini, saya ucapkan selamat. Ada dari teman-teman dari BINUS, teman-teman dari Undip, dari Bina Dharma, dari UI, dari Universitas Syakwala, dari Universitas Pembangunan Jaya, dari ITB, dari Politeknik Statistik STIS, dari Universitas Krishna Satya Wacana, dan Universitas Hasanuddin. Semoga ini menjadi awal yang baik dalam pengembangan AI Center di Indonesia. Dan pada seluruh perguruan tinggi yang lain yang belum bergabung, kami persilahkan untuk memanfaatkan ini melalui skema-skema riset maupun skema-skema matching fund di Derika. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Shalom. Om Santi 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 Om.
Baik, terima kasih Pak Dirjen atas arahan sekaligus sambutannya. Mari kita saksikan bersama video bumper Dikti AI Center.
Memasuki industri 4.0, kehidupan kita saat ini tidak dapat dipisahkan dari teknologi dan sistem artificial intelligence, atau yang lebih kita kenal dengan AI. Artificial intelligence atau kecerdasan artifisial adalah sebuah sistem di mana kecerdasan yang dimiliki manusia dimodelkan di dalam mesin dan diprogram agar dapat berpikir sama seperti manusia.
Siapa yang menguasai AI, dia yang akan berpotensi menguasai dunia.
Dikti AI Center hadir dengan superkomputer berkemampuan komputasi 25 petaflops, dapat dimanfaatkan oleh seluruh sivitas akademika perguruan tinggi dan mitra industrinya. Selain fasilitas teknologi, Dikti AI Center juga akan menyelenggarakan pelatihan, pendampingan, webinar, serta hackathon. Untuk itu, bagi seluruh perguruan tinggi di Indonesia, mari bersama-sama memaksimalkan serta memanfaatkan Dikti AI Center untuk menciptakan ekosistem penelitian dan inovasi kecerdasan artifisial di perguruan tinggi.
Ya, hadirin yang berbahagia, telah hadir perwakilan salah satu use case terpilih, yaitu Bapak Dr. Adi Wibowo. Bapak Adi selaku penanggung jawab atau PIC dari Universitas Diponegoro. Monitor, Bapak Adi, apakah sudah tersambung?
Ya, ya Mbak. Halo, selamat siang.
Halo, selamat siang Pak Adi.
Selamat siang.
Senang rasanya bisa bertatap muka di Zoom ini ya Pak ya, karena kemarin kita hanya koordinasi via WA, begitu ya Pak ya. Semoga sehat selalu.
Amin.
Oke, Pak Adi, saya memohon bantuan dari Pak Adi nih untuk memberikan testimoni. Pak Adi di sini selaku perwakilan, Pak Adi bisa memperkenalkan diri terlebih dahulu, Pak, lalu Bapak bisa jelaskan terkait judul atau tema detail use case dari Universitas Diponegoro sendiri, Pak, karena dari sebanyak 41 proposal yang masuk ke kami, proposal Undip salah satunya bisa terpilih. Silakan Pak, bagaimana tanggapan Bapak?
Baik, terima kasih Mbak. Jadi perkenalkan, nama saya Adi Wibowo, saya dosen program studi informatika di Universitas Diponegoro. Dalam kesempatan ini, sebelum kami menyampaikan use case, kami menyampaikan ucapan terima kasih kepada Pak Dirjen Dikti Ristek, Prof. Nizam, dan juga Prof. Cici, dan juga tim Dikti AI Center yang telah memberikan kesempatan kami untuk memperoleh akses ke Dikti AI Center. Dalam use case yang kami ajukan dalam proposal kemarin, kami kebetulan melakukan penelitian terkait implementasi kecerdasan buatan untuk peningkatan sistem peringatan dini gempa bumi dan tsunami dengan multisensor. Penelitian ini kolaborasi dengan Institut Teknologi Bandung di Geofisika, kemudian di Universitas Gajah Mada di Teknik Geodesi, dan juga tentunya penyedia data utama untuk sensor tersebut adalah dari BMKG, Badan Meteorologi, Klimatologi, Geofisika, dan juga Real Time Global Navigation Satellite System (GNSS) yang diperoleh dari BIG, ya. BIG. Selain itu juga ada data dari remote sensing dari GPL dan NOAA platform. Ini datanya cukup sangat besar gitu. Jadi kami sangat berterima kasih sekali mendapatkan kesempatan untuk akses Dikti AI Center ini, karena betul-betul kami kemarin sempat butuh waktu yang lama untuk memperoleh kecerdasan buatan yang terbaik gitu ya. Begitu Mbak. Mungkin sekilas.
Baik, menarik sekali ya Pak Adi untuk temanya sendiri gitu. Nah, kalau untuk kendala yang dihadapi terkait kemampuan komputasi yang dimiliki untuk penelitian AI di Undip sendiri, apa aja Pak kendalanya Pak?
Ya, jadi tentunya kemampuan komputasi menjadi sumber salah satu ini ya sarana yang wajib dimiliki ya. Kebetulan kami hanya memiliki empat server yang memiliki GPU gitu ya, dan masih GPU-nya juga masih sangat kecil, 8 GB gitu ya. Jadi kemarin pas kami mencoba running ya, beberapa data kita butuh hampir 20 hari untuk running gitu ya. Jadi sempat kami mau akses ke Amazon AWS gitu ya, terus setelah kita hitung-hitung ternyata mahal, ya sudah kita beli ini aja lah perangkat gitu ya. 4, kemudian kita coba paralel juga masih waktunya cukup lama gitu ya untuk mendapatkan model, terutama model kami di saat awal-awal kita coba menambah beberapa arsitektur yang cukup rumit, yang dalam, yang sangat deep gitu, yang biasanya kalau mungkin standar arsitektur maksimal 10 layer, kami coba hampir ratusan layer gitu, sehingga sangat sulit gitu ya untuk running dapat hasil yang cepat. Ini yang jadi kendala, terutama kendala ini. Terus datanya juga sangat besar, jadi kalau data seismik sendiri ada per tahun itu 8 tera, 8 tera kami punya 4 tahun, jadi ada 32 tera yang kami harus persiapkan untuk pengolahannya, dan RAM komputer kami hanya mampu 64 GB. Jadi kalau running untuk ini maka kami harus split gitu. Jadi cukup berat sebetulnya. Jadi ini fasilitas ini sangat-sangat helpful kami ya, sangat membantu, terutama karena memang kebutuhan infrastruktur sangat tinggi di penelitian kami.
Baik, terima kasih Pak Adi. Jadi memang sebelumnya butuh waktu sampai 20 hari ya Pak ya untuk running ya. Mudah-mudahan nanti bisa running cepat gitu ketika nanti sudah melakukan pemanfaatan dengan Dikti AI Center. Lalu terakhir nih Pak Adi, kalau untuk harapan Bapak sendiri atas fasilitas Dikti AI Center ini seperti apa Pak? Karena kan ini kami juga baru berjalan di periode 1 ya Pak. Nanti kami akan ada beberapa periode selanjutnya lagi. Jadi nanti bagi perguruan tinggi yang juga ingin mengajukan proposal juga mungkin bisa belajar dari Pak Adi ini. Bagaimana Pak untuk harapannya?
Yang pertama, harapan pertama kami adalah availability-nya ya, karena kebetulan availability ini menjadi salah satu yang agak berat juga di kami gitu ya. Saat jujur dengan adanya fasilitas ini, Dikti AI Center, kami tidak perlu ngurusin listriknya, air conditionernya, kemudian dan segalanya gitu, internetnya dan seterusnya gitu. Karena kendala tadi sebelumnya mungkin saya lupa menyampaikan kendala, yaitu koneksi internet di server itu yang kadang-kadang mati atau listrik mati gitu. Jadi harapannya availability dari Dikti AI Center itu bisa bagus gitu ya, maintenance bagus, sehingga kami dalam mengakses itu tidak ada kendala, tidak ada tidak ada hambatan, dan juga pas running itu bisa smooth gitu, jadi bisa hasil yang diperoleh bagus. Yang kedua tentunya adalah harapannya nanti maintenance-nya juga terus gitu ya, dan mungkin kapasitasnya juga terus ditambah, sehingga kami misalkan ada use case baru, data baru, sehingga bisa meningkat. Dan yang ketiga tentunya adalah harapannya adalah kami bisa terus mengakses gitu ya, karena kalau kita harus membeli, harus menginvestasi, mungkin Undip moga-moga nanti bisa memberikan investasi, tapi dengan terus-menerus kami jadinya bisa continue memiliki semacam roadmap yang jelas bahwa kita memang sudah ada arsitektur atau infrastruktur yang kita gunakan, sehingga kita bisa meng-roadmap yang lebih baik, dan kita nggak usah mikirin arsitekturnya tadi gitu ya. Kita di saat mau desain seberapa rumit dan seterusnya, kita bisa tetap berharap bisa Dikti AI Center ini terus berjalan dan mensupport penelitian kami, dan tentunya penelitian yang lebih banyak lagi. Mungkin itu Mbak.
Baik, terima kasih banyak Pak Adi atas testimoninya nih Pak. Ini real ya Pak ya, testimoni langsung ya Pak ya. Jadi Bapak Ibu, jadi semoga semangat Pak Adi ini bisa memberikan dampak juga kepada perguruan tinggi lainnya yang juga ingin mengajukan proposal kepada Dikti AI Center. Kami persilakan karena seperti yang sudah saya sampaikan untuk 10 ini adalah periode pertama dan nanti akan ada periode selanjutnya. Dan dalam waktu dekat kita akan terus koordinasi ya Pak Adi ya terkait tindak lanjut dari pemanfaatan Dikti AI Center. Sehat selalu Pak Adi. Terima kasih.
Terima kasih.
Ya, baik Bapak Ibu, untuk pembukaan proposal periode kedua juga nanti kami akan terus update. Jadi silakan bagi Bapak Ibu atau perwakilan perguruan tinggi yang ingin mengajukan dapat mempersiapkan proposal untuk bisa berpartisipasi dalam pengajuan di periode kedua. Baik Bapak Ibu, marilah kita saksikan bersama video bumper perwakilan dari para PIC untuk 10 use case terpilih di Dikti AI Center tahun 2022 pada periode 1.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Adi Wibowo, dosen Departemen Informatika Universitas Diponegoro. Terima kasih kepada Dikti AI Center yang telah memberikan kepercayaan kepada kami untuk bisa mengakses AI Center yang dimiliki oleh Dikti. Kami akan memanfaatkan AI Center dari Dikti untuk pengolahan data gempa, seismik maupun GNSS dan juga data remote sensing untuk kebencanaan di Indonesia.
Perkenalkan, kami Profesor Al-Hadi Bustaman PhD dari Departemen Matematika FMIPA UI. Kami mengucapkan terima kasih atas kesempatan yang diberikan untuk bisa menggunakan fasilitas AI Center dari Dikti. Salah satu pekerjaan yang kami kerjakan saat ini adalah bagaimana mendeteksi penyakit yang ada di dalam tubuh manusia, khususnya penyakit-penyakit kronis seperti penyakit diabetes, yang berhubungan dengan jantung, dengan penyakit stroke, dan sebagainya, dengan pendekatan data science dan AI menggunakan citra fundus image yang ada di retina. Ada beberapa penyakit yang sudah kami deteksi dan kami berharap akan lebih dari 30 penyakit yang bisa kita selesaikan dalam waktu dekat. Kami berharap output dari program ini nanti dapat diterapkan di rumah-rumah sakit, khususnya saat ini di Rumah Sakit Universitas Indonesia, dan sebagai salah satu sumbangan untuk bangsa Indonesia tentunya.
Perkenalkan, nama saya Suryadi Putra Leotimena, saya dari Universitas Bina Nusantara. Saya menjabat sebagai B Embedded Research Group Manager dan dosen senior di jurusan Sistem Komputer dan Magister Teknik Informatika di Bina Nusantara. Kami membutuhkan fasilitas AI yang dapat menunjang dalam penyelesaian skripsi, tesis, dan disertasi, yang terutama yang berbasis AI. Karena kami percaya pada akhirnya semuanya akan berbasis AI. Internet of Things dan Digital Twins yang bisa menghubungkan dunia fisik dengan versi digitalnya dan metaverse. Kami sudah melihat NVIDIA CEO Jensen Huang memberikan banyak contoh Digital Twins yang sudah dibuat juga oleh para pemain besar dunia. Proyek penelitian yang akan dibuat adalah pembuatan stetoskop digital yang dapat mengenali gejala dini pneumonia balita dengan menggunakan mikrofon dan penguat suara digital, pengambilan dan perekaman sampel-sampel suara paru-paru dan jantung, dilakukan pada puskesmas yang menjadi tempat penelitian. Nanti dibantu oleh para tim dokter untuk menentukan label apakah suara tersebut adalah suara normal atau sudah bergejala pneumonia. Kumpulan sampel data tersebut akan menjadi dataset untuk melatih model CNN untuk mengenali gejala sakit tersebut. Penerapan stetoskop digital pada puskesmas di lokasi lain, terutama yang terpencil, ketika melakukan pendeteksian seseorang balita, maka inferensi dapat dilakukan dan hasilnya dapat langsung ditampilkan pada layar terminal dengan keterangan diagnosa dan cara penanganan lebih lanjut. Output yang diharapkan berupa prototipe stetoskop digital dan koneksi secara satelit, kemudian bisa ditempatkan pada daerah-daerah terpencil, dan juga menghasilkan dataset suara rekaman pneumonia balita agar dapat digunakan oleh para peneliti tim lain.
Perkenalkan, nama saya Ali Misbullah. Saat ini saya bekerja sebagai dosen di jurusan Informatika, Fakultas MIPA Universitas Syahkollah. Terima kasih banyak sebelumnya karena telah mengizinkan kami sebagai salah satu perwakilan terpilih untuk use case AI Dikti Center. Saat ini, penelitian-penelitian yang dilakukan oleh dosen dan mahasiswa di jurusan Informatika yang berkaitan dengan bidang deep learning, diantaranya speech processing, seperti sistem pengenalan suara, speaker recognition, face recognition, image recognition, image translation, dan text processing seperti text summarization. Beberapa output yang didapatkan dari penelitian di bidang tersebut diantaranya dapat diimplementasikan secara langsung ke prototype produk seperti absensi perkuliahan menggunakan face recognition, sistem road guidance menggunakan speed recognition. Selain itu, penelitian yang dilakukan juga dapat meningkatkan publikasi dosen dan mahasiswa baik pada level nasional maupun internasional. Harapannya, semoga dengan tersedianya infrastruktur AI Dikti Center dapat mendorong peningkatan kualitas penelitian di Universitas Syahkuala, khususnya dan universitas di Indonesia secara umum.
Saya Edi Surya Negara dari Universitas Bina Dharma. Proyek yang akan kami lakukan pada Dikti AI Center ini adalah mengembangkan sebuah community detection berbasis AI, di mana nanti kami akan memetakan seluruh potensi, baik itu peneliti dan dosen yang ada di seluruh Indonesia berdasarkan community dan bidang disiplin ilmu. Di sini nanti kita akan menggunakan AI di dalam proses deteksi komunitasnya, sehingga nanti kita bisa mengetahui dan memprediksi komunitas-komunitas bidang keilmuan apa, dan siapa, dan bagaimana jaringannya yang akan berkembang di seluruh Indonesia. Data ini kita perlukan, atau informasi ini kita perlukan untuk memetakan kekuatan penelitian dan memetakan disiplin penelitian apa unggulan yang ada di Indonesia. Output yang kita harapkan daripada proyek ini adalah sebuah sistem analitik berbasis AI, dan nantinya ini akan kita harapkan bisa digunakan oleh pemerintah, dalam hal ini Kemendikbud, untuk memetakan potensi-potensi riset dan jaringan sosial peneliti dan dosen yang ada di Indonesia. Kemudian nanti diharapkan juga beberapa publikasi yang ingin kita targetkan daripada proyek ini.
Perkenalkan, nama saya Hindrianto Diponomo dari Fakultas Teknologi Informasi Universitas Kristen Satya Wacana, Salatiga. Kami mengucapkan terima kasih atas kepercayaan yang diberikan kepada kami, sehingga kami bisa memanfaatkan fasilitas yang ada di Dikti AI Center. Dengan memanfaatkan fasilitas yang diberikan, antara lain adalah penerapan evolutionary algorithm pada deep neural network, atau sering disebut dengan neuroevolution. Tujuan dari penelitian ini adalah untuk mengeksplorasi potensi neuroevolution pada deep neural network. Eksplorasi akan difokuskan pada optimalisasi konfigurasi deep neural network dan optimalisasi proses learning di deep neural network. Luaran yang diharapkan dari penelitian ini adalah model neuroevolution untuk sequential decision making. Adapun sequential decision making banyak dibutuhkan pada berbagai aplikasi, seperti pada continuous monitoring berbasis IoT dan autonomous vehicle.
Perkenalkan, saya Milai dari program studi ilmu komputer Departemen Matematika Fakultas MIPA Universitas Hasanuddin. Itu kami ucapkan terima kasih banyak telah diundang bergabung dengan Dikti AI Center. Saat ini kami sedang berkolaborasi dengan PT Widya Institute of Technology, UMG Group, dan Samsung Research and Development Indonesia dalam mengembangkan sistem yang kami sebut sebagai Textpedia AI. Kami juga bekerja sama dengan Fakultas Kedokteran Universitas Hasanuddin, Dinas Kesehatan Pemerintah Kota Makassar, dan salah satu industri laboratorium kesehatan terbesar di Indonesia dalam mengembangkan sistem AI untuk rekomendasi cepat diagnosa hasil pembacaan 12 jenis grafik EKG jantung, serta penelitian AI pada sektor lain yang bekerjasama dengan industri seperti Kala Group, Indosat Toledo, Telkomsel, dan serta lainnya.
Perkenalkan, nama saya Nur Udin, dosen program studi informatika Universitas Pembangunan Jaya di Tangerang Selatan. Pertama, saya ingin mengucapkan banyak terima kasih atas kesempatan yang diberikan kepada kami untuk menggunakan fasilitas Dikti AI Center ini. Fasilitas tersebut akan kami gunakan untuk membangun model deep learning yang akan kami gunakan untuk mengenali objek gambar, guna menunjang penelitian kami dalam pengembangan autonomous mobile robot berbasis computer vision. Autonomous mobile robot merupakan topik penelitian yang telah kami lakukan sejak beberapa tahun terakhir. Kami telah mengembangkan beberapa konsep autonomous mobile robot berbasis data navigasi yang meliputi posisi dan orientasi robot. Penelitian ini kami lanjutkan dengan mengembangkan autonomous mobile robot berbasis vision, di mana kami mengaplikasikan computer vision dan artificial intelligence dalam autonomous robot tersebut, sehingga robot memiliki kemampuan untuk mengenali objek gambar di sekitarnya. Adanya fasilitas Dikti AI Center ini sangat menunjang kami dalam melakukan penelitian tersebut, terutama dalam membangun model artificial intelligence, dalam hal ini deep learning, di mana proses komputasi pada saat proses pembelajaran sangat berat. Selanjutnya nanti model deep learning yang akan kami hasilkan akan kami implementasikan dalam sebuah embedded system. Output dari penelitian ini akan berupa sebuah prototype autonomous mobile robot berbasis vision dan publikasi di jurnal internasional bereputasi.
Kami dari Politeknik Statistika STIS, saya Ari Wahyu Wijayanto, Ketua Unit Kajian Komputasi Statistik. Kami mengucapkan terima kasih kepada AI Center Dikti atas kesempatan yang diberikan kepada kami. Pemanfaatan AI Center Dikti yang kami rencanakan adalah riset pada bidang spatial artificial intelligence, yaitu pemanfaatan data penginderaan jauh atau remote sensing dengan citra satelit optik resolusi menengah, tinggi, dan sangat tinggi untuk pemetaan kemiskinan nasional dan monitoring kawasan urban. Penelitian ini selain berkolaborasi dengan Badan Pusat Statistik, juga berkolaborasi dengan Badan Riset dan Inovasi Nasional atau BRIN, Center for Remote Sensing ITB, serta UNECE Machine Learning Group. Harapan kami, pemanfaatan AI Center Dikti ini dapat mengakselerasi capaian alternatif data pemanfaatan pemetaan kemiskinan nasional menggunakan citra satelit dan big data dengan teknik deep learning untuk mendukung pembangunan nasional yang lebih menyeluruh dan tepat sasaran.
Perkenalkan, nama saya Ayu Purwarianti dari Pusat Artificial Intelligence ITB. Sebelumnya, izinkan saya mengucapkan terima kasih karena diberi kesempatan untuk turut serta dalam Pusat Artificial Intelligence Dikti. Dalam penelitian kali ini, kami bekerja sama dengan berbagai universitas lain. Beberapa orang diantaranya seperti misalnya Samuel Cahaya Wijaya, Gendra Winata, Fajri Koto, dan lain-lain. Kami bermaksud untuk membangun pre-trained model bagi bahasa Indonesia dan berbagai bahasa daerah di Indonesia, seperti misalnya bahasa Sunda, Jawa, Bali, Minangkabau, dan lain-lain. Pre-trained model yang kami bangun sekarang ini adalah pre-trained yang menggunakan topologi T5 dan GPT-2, baik yang large maupun XL. Dan ini membutuhkan komputasi yang sangat besar. Membutuhkan untuk data sekitar 30-35 GB, di mana di dalamnya ada sekitar 300 juta kalimat, yaitu mencakup sekitar 4 miliar kata. Karena komputasi yang sangat besar itu, maka kami membutuhkan penggunaan HPC dalam membangun pre-train ini. Dan secara output penelitian, nanti pre-trained model ini bisa digunakan oleh berbagai peneliti di Indonesia untuk membangun berbagai NLP model bahasa Indonesia dan bahasa daerah. Contohnya seperti sentiment analysis, emotion classification, dan lain-lain.
Years ago, all of this was science fiction. 10 years ago, it was a dream. Today, we're living it. Let's get started.
Baik, saya ingin menyapa terlebih dahulu. Ini nampaknya selamat siang kepada yang terhormat Ibu Ses, Ibu Profesor Cici Sri Cahyandari, selaku PLT Sekretaris Ditjen Dikti Ristek. Terima kasih Bu Ses telah hadir dalam acara siang hari ini. Izin melaporkan Bu Ses, kami sedang melakukan webinar pada siang hari ini. Apakah ada arahan yang ingin disampaikan Bu Ses?
Terima kasih Mbak Reli. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera, namo buddhaya, dan sehat selalu. Pertama-tama saya apresiasi pada acara siang hari ini terkait dengan kick-off AI Center yang ada di kemudian PD Dikti berkolaborasi dengan NVIDIA. Ini ada saya melihat Pak Rene ada di sini. Terima kasih Pak Rene, selamat siang. Sehat selalu ya Pak.
Selamat siang Ibu.
Jadi kami sangat apresiasi bahwa kegiatan-kegiatan seperti ini atau adanya AI Center yang ada di kementerian ini bisa juga dimanfaatkan oleh seluruh stakeholder karena kita ingin adanya sharing resources, karena kalau kemudian kita melihat bahwa resources ini bisa lebih dimanfaatkan terutama untuk menunjang penelitian-penelitian yang ada di berbagai perguruan tinggi yang ada di Indonesia ini, apalagi sekarang sudah ada 10 peneliti yang juga sudah diberikan akses untuk bisa menggunakan AI Center yang ada di Ditjen Dikti Ristek ini. Harapan kami ke depan bahwa program-program ini, adanya AI Center ini justru lebih dapat dimanfaatkan dan diberdayakan untuk menunjang seluruh bisnis proses atau tridharma yang ada di perguruan tinggi. Jadi mungkin tidak hanya untuk dosen begitu ya, tetapi ini nantinya juga bisa untuk menunjang kebijakan-kebijakan, penelitian-penelitian dari sisi aspek untuk kebijakan-kebijakan yang ada dari mitra kami, mitra-mitra Dikti Ristek, dan juga mungkin bisa juga sebagai suatu proses untuk pembelajaran dalam hal ini mahasiswa-mahasiswa MBKM itu kan juga bisa melakukan proses pembelajaran mengenal terkait dengan AI melalui AI Center ini. Jadi harapan kami ke depan ini kerjasama yang sudah sangat erat dalam hal ini dengan adanya NVIDIA, kemudian dengan platform yang kita punya, itu bisa kita integrasikan untuk mendukung kemajuan perkembangan ilmu pengetahuan dan teknologi yang ada di Indonesia. Saya kira itu, terus kami mohon dukungannya Pak Rene untuk kemudian kolaborasi di dalam pengembangan AI Center ini. Saya kira begitu, terima kasih juga untuk seluruh tim di AI Center yang selama ini juga sudah bekerja secara smart, bekerja cerdas, begitu ya, untuk bisa mewujudkan dalam hal ini adalah obsesi dan juga sebenarnya sebagai salah satu tugas kami yang ada di Kementerian Ditjen Dikti Ristek di dalam pengembangan AI Center ini. Saya kira itu Mbak Rene, Mbak Reli, terima kasih juga Pak Rene dan juga para peneliti. Saat ini kita bangun kolaborasi kita bersama-sama untuk optimalisasi resources yang ada di Kementerian. Terima kasih dan Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Bu Ses izin ini saya Anggi Bu.
Oh iya Mbak Anggi, Mbak Reli ada. Iya, mohon maaf
Mbak
paralel
ya Bu ya dengan
sama-sama Ayu, sama-sama cantiknya soalnya.
Terima kasih Bu Ses. Baik Bu Ses, terima kasih banyak atas arahan yang telah diberikan. Menjadi harapan kita semua tentunya ya Bu Ses ya dari Ditjen Dikti Ristek untuk mengembangkan Dikti AI Center untuk selanjutnya. Terima kasih Bu Ses atas waktunya. Baik, hadirin Bapak Ibu, telah kita saksikan bersama tadi untuk 10 PIC dari masing-masing perwakilan newscast terpilih yang berhak mendapatkan pemanfaatan fasilitas Dikti AI Center. Nah, karena ini sudah memasuki acara utama, Bapak Ibu, langsung saja kita akan saksikan bersama-sama untuk webinar pada siang hari ini. Dan untuk sesi ini saya tidak sendiri karena saya dibantu oleh Ibu Lina Wirahadi, yang akan bertugas sebagai moderator pada siang hari ini. Monitor Ibu Lina, apakah sudah tersambung Bu Lina?
Iya, Ibu Anggi, sudah tersambung.
Baik, apa kabar Bu Lina?
Baik, baik. Bagaimana kabar Bu Anggi? Sehat selalu ya Bu, salam sehat.
Alhamdulillah sehat Bu Lina. Baik Bu Lina, saya persilakan waktu untuk Bu Lina memandu webinar pada siang hari ini. Nanti juga mungkin kita akan ada sesi diskusi tanya jawab ya Bu Lina ya. Jadi silakan bagi
Betul
Bapak
sekali.
Ibu yang memiliki pertanyaan, silakan drop di kolom Q&A. Nanti akan coba dibantu oleh Bu Lina untuk langsung dijawab oleh pemateri. Dan bagi 5 pertanyaan terbaik nantinya akan mendapatkan hadiah eksklusif dari Appsindo. Dan nanti kami akan memberikan atau menginformasikan untuk menghubungi pengambilan hadiahnya seperti itu. Baik, saya persilakan Bu Lina.
Terima kasih Bu Anggi. Selamat siang Bapak Ibu sekalian hadirin terhormat. Thank you Bu Anggi. Now we will move to the next agenda, and then it will be the webinar. So as we know, as the word of metaverse become more and more popular in every conversation on VR, AR, virtual communities, and the future of 3D graphics, NVIDIA Omniverse brings millions more in the metaverse as it connects the words by enabling the vision of the metaverse to become reality. So the next on the agenda, we will learn more about what NVIDIA Omniverse is, and then allow me to briefly introduce our speaker today. And then we have Mr. Raghu Ganti. Mr. Raghu Ganti is a sales leader with over 17 years of experience guiding businesses across Asian Pacific in auto, aero, medical, and industrial equipment industry transform using technology analytics. Mr. Raghu also has 14 years experiences in digital twins and virtual worlds. Mr. Raghu is the regional sales leader for Profis and NVIDIA Enterprise Software, including NVIDIA Virtual GPU, NVIDIA AI Enterprise, and NVIDIA Omniverse. Prior to NVIDIA, Mr. Raghu worked at Dassault Systems, Siemens, Rockwell Collins, and Caterpillar in various technology, consulting, and management roles. Mr. Raghu holds a master's degree from the University of Texas in manufacturing engineering and an MBA from ISAC and Mannheim Business School. Being said, Mr. Raghu, the floor is yours.
Thank you, Bulina. Assalamu alaikum and salamat siang. Okay, with that said, let me get started there. Thanks for sparing your time today. And what I'm going to do is in the next 1 hour or so, let me share what I know a little bit about what digital twins are and what and where the virtual worlds or your so-called metaverse is going, right? So we're going to see that also. And I'm going to share it more on to also help you understand what exactly we mean by this metaverse. So before I get started, I would sincerely say, hey, everybody's got a smartphone. Go ahead, open it up and scan this and then register for the GTC. Why? Because you will see in the next week when Jensen announces that is our CEO, you will see some amazing things that is going to talk about Omnivores, which is creation of these virtual worlds and all the technologies that enable this to happen, right? So, and post this session, if you have any questions or you are looking on embracing these technologies or you don't know where to start, please feel free to reach out to our Lina Bulina or Park Rainey and everybody else. And we would be happy to assist you or even just answer any questions you may have, right? What I'm going to do is, I'm going to start off with a video here. So why is this necessary? I'll come down to it. But what you're seeing here is a virtual model. It is not a video capture, but rather a 3D rendered model. So, and what if you're able to, I always come with this question, right? What if you're able to recreate these artifacts and so on? Will you be able to preserve your culture better? Because a lot of the times, as we see, the way that technology is progressing, we have forgotten a lot of our past. So if you are able to capture it, and if you are able to capture these and showcase these fruits and vegetables, will we get better price for our farmers? And if, as we see here, all of these digital twins, the key is not just visualization, but all the laws of physics have to be adhered to. So here is an example. Using these physics, can we teach students to learn better? Or can we visualize things? I'll come into a little more deeper into each of these examples that will help explore what was not possible before. And we will also see what are the technologies that are enabling these happen right now at this moment. And a lot of this, the skin simulation for that matter, or digital twins where you are able to simulate CFD instead of days and weeks in fraction of seconds and so on, or teaching robots or autonomous vehicles, because we did see that quite a bit when folks mentioned it earlier, synthetic data, and capturing all of this, all the materials and the way these particles behave as realistically as possible, right? And all of these features, all that you see, are essential part of the whole Omniverse. And this is our flagship showcase. We call it as the factory of the future. A factory is, a factory is so complex because it has so many moving parts. But yeah, here with BMW, we were able to recreate it. And this is a facial human animation. So you can use a voice to essentially capture how the skin and the muscles move. Or digital earth too, I'll go a little bit more deeper because this is of very, very big consequence to all of us in Indonesia. And then of course, signal propagation, or for that matter, smart avatars as we call it, right? Because avatars are going to be everywhere we see. And all of this is being led, and we are at the forefront of all of these different technologies as we call it. And is this video coming out with an audio to you guys or no? Are you getting the audio from here when I'm playing it?
Videonya, I don't think we heard the audio from the video.
Yeah, we didn't get the audio, Raghu.
Share sound. Okay, I got it. Give me a minute. Because this is a video that essentially, it was in last November, where our CEO Jensen essentially talked about how to build these
Hopefully
virtual
in a
worlds
couple of years,
in Omniverse.
Data will stream into a digital twin of Earth, running in Omniverse. An ensemble of physics ML models will predict the climate. Let's talk about Omniverse. The internet changed everything. It's surely an understatement. We are always connected now. The internet is essentially a digital overlay on the world. The overlay is largely 2D information: text, voice, images, video. But that's about to change. We now have the technology to create new 3D virtual worlds or model our physical world. These virtual worlds will obey the laws of physics, or not. There can be AI or friends with you. We will jump from one world to another, like we do on the web with hypertext. This new world will be much larger than the physical world. We will buy and own 3D things, like we buy 2D songs and books today. We will buy, own, sell homes, furniture, cars, luxury goods, and art in this world. Creators will make more things in virtual worlds than they do in the physical world.
We are already doing it because I don't know, a lot of us play video games. I don't know how many of you play Fortnite, or for that matter, all of these massive online games, right? These are all part of a sort of a virtual world that we live in. And of course, the skins that you use, the
is very different than a game engine.
Are all creators that make it.
Omniverse is designed to be data center scale, and hopefully someday planetary scale.
I think, yeah, because you see, that is the whole vision. So what is Omniverse? Omniverse, because all of this, if you can take it as Autodesk, when you create a product with an Autodesk, it is an Autodesk world. And then when you bring it into the pipeline, into something else, we're using Adobe, or when you're using it for marketing, you're creating this Adobe world. And Omniverse is a platform that essentially bring these two worlds together. And that is what we are trying to do. It's a platform for, or you can say, virtual world collaboration or a metaverse collaboration, as we say it, right? And of course, you would see digital twins virtually across everywhere. And we are seeing that more and more happening actually in these recent times. And some of these examples, which I will be going into quite detail along with the videos and so on, the applications are enormous, right? And of course, what is causing these changes, right? And then we can see what is the reason why people are now looking at omniverse or / metaverses. And yeah, the key thing is it requires quite a bit of few technologies. But anything that, and why do you think is it a challenge right now to even create a metaverse or an omniverse or a virtual world? Because we have large teams. And what is the motivation for this? Because the teams are large. Say, for example, you're building the capital city, right? Nusantara. So to create that, you don't have everybody sitting in Jakarta and trying to design it. You have people from across the world, large teams, or even within whole Indonesia itself, spread across multiple islands. And then they don't just use one tool, they use multiple tools. It could be Autodesk, Maya, Max, Unreal, Blender, name it, right? And then and it's so complex, right? The whole workflow is itself complex. And this is what Omniverse does, actually brings all of these diverse people with diverse skill set, irrespective of the tools that you use, and wherever you are, and no matter how complex, to collaborate in near real time, as we call it. And the key enablers, and why is this happening now? Because of these 4 pillars, as we call it, right? These 4 pillars are very, very essential to create something of the sort of a huge virtual world. One is RTX technology, which is the backbone for creating realistic looking material. Because if I show you, or I don't know how many of you have played video games like Minecraft or Legos, right? Yeah, if I create a building with a Lego or Minecraft, in a Minecraft, it still looks pretty choppy. It does not look real. It looks like a video game. But when you're trying to create a virtual world, you should not be able to distinguish between what is available in the real to what is available in the virtual world. And the second pillar that is enabling this transformation is, again, being able to compute at such a huge scale, the data center scale, right? Thousands of GPUs on thousands of nodes, etc. And that is what we are at the forefront of driving this platforms to high performance compute as such. And of course, I just gave you an example earlier about an Adobe world with an Autodesk world and many different worlds. People interact in these worlds because if you are using Autodesk, you are very good at that. You're an expert at it. And then if I'm using Unreal, I'm an expert at it. But again, in the end of the day, we all need to collaborate. But there is no common format, just like what HTML is, because I'm able to move from one website into another or one world into another seamlessly, is because HTML is the common platform for internet. Similarly, there is no common platform or a denominator for a 3D world. And that is what USD does. USD is from Pixar. I'll go into a little bit detail explaining what exactly it is in some time there. And then, of course, we all before me for the last 45 minutes to 1 hour, everybody was talking about AI. AI revolution is coming. Even President Park Jacoby was talking about AI and how it's going to transform our lives. And that is happening. All these put together is the right set of ingredients to create these virtual worlds. And these virtual worlds are going to be so big and so vast that, even it's much bigger than, Earth is just one planet. But imagine thousands of different planets put together and so on, right? So it's going to be much. And the kind of economy on that inside this virtual world will surpass what's existing in this real world, as we call it. And of course, the key technology, as we see, right, is the Rtx Renderer. It is the renderer. It's used to build and simulate as realistically as possible photoreal, physically accurate materials, which are very, very important, right? And then the GPUs themselves have the core technologies, both of the CUDA cores, Tensor cores, and Rtx cores to do all these different jobs and then efficiently scale across for any size of problem that you're trying to solve. And and what is in it for you? How do you get started? You might say, hey, Raghu, that's nice. It looks interesting. How do I get started, right? So you say, hey, and then what kind of tools do we have? The first and foremost is, of course, the GPUs, using the right set of GPUs, and of course the Ampere right now, what we call it as using the professional series GPUs. And for every sort of workload, be it the A2000, that's from the smallest workload to the largest, as we call it, the A6000s, right? These are the basic building blocks for you to be able to efficiently scale across the different kinds of scenes that you're trying to create. And yep, and then what do you get? You get this. What do you see across? This is a factory of the future from BMW. And why is this so massive? Because yeah, a factory is so complex, right? We've seen it. You have people using multiple tools, so many processes in place, because they could be using CATIA, Siemens, Point Cloud's their own in-house tools. But again, these are different worlds and never. And then as you see, this is not a picture. It's not because this is a real live digital twin. So whatever you make changes you make here, you can easily replicate it on the factory floor to see, and then yeah, you can make these changes, you understand its cause and effects, and you replicate it on the shop floor. Or for that matter, here you're teaching a human to essentially, when you're setting up a new factory line, how exactly the ergonomics should be, and so on. So all of this can be essentially done in a digital world, and before you move it on to a physical world, right? So that is an essential piece, or the only reason why you would need these virtual twins. And of course, with the pandemic, we have seen all of this bringing it to a standstill. I want to expand my line. I have to bring in some experts from Germany, but the whole world is locked. And so yeah, we are talking about people not being able to do it. Should I stop my work? No. And that is where this whole process comes in, being able to recreate what exactly, and then an expert sitting in Germany is able to collaborate and teach a worker using an avatar or whatever you can call it, or a virtual human being, right? And all of it, and then many other use cases, as we call it. And then, okay, let me come here a little more. And then, of course, is that the only use case? No, because a lot of these, somebody talked about autonomous vehicles earlier in their research. So all of this, because a factory, even in the shop floors or the warehouses, right, you would have autonomous vehicles or AGVs essentially. So using Omniverse to train these models, because obviously you are moving towards an AI adoption and all of it. So using synthetic data, Omniverse can help you create that, right? So you're able to train your models faster. Say, for example, you can randomize the domains and really do it so to do all of the scenarios that you can account for, because you can't really capture all the data in real time, but you can create synthetic data and using multiple sensors and so on, right? So these are some of the examples there, what you could see, especially when it comes to the factory of the future. A city is no different, because a city is as well equally complex. So you just have to start building it somewhere. You need to bring in these different pieces and then, yeah, and start deploying it.
Extreme wild.
And here is an example. This is a pretty nice example of where visualization plus AI comes into picture. And this is as well a digital twin. Why is it so important, you might say? Because it involves fire simulation using AI. Fire is traditionally plasma, right? It's not a fluid, it's not a gas, it's not a liquid. So plasma behaves extremely different, or the behavior is completely different from a fluid or a gas. So, and then, yeah, it's hard to determine empirically as well to how the behavior happens. So Lockheed and Martin here is essentially trying to find out based on certain terrain and characteristics, right? Wants to predict how the fire will propagate. So what is in it for it? You can take disaster mitigation actions. If a fire is occurring, this is as well. And similar process applies to fluids, that is liquids. So which could be tsunamis in our case, because yeah, we are in a Pacific Ring of Fire. If we are able to predict that using these technologies, then perhaps we could very well understand, save thousands of lives, because I still remember the December 24th, Boxing Day. So it helps not just to understand what happens, but also helps us save lives and impact people around us.
Extreme wildfires have impacted millions of lives, causing billions of dollars in damage around the world. NVIDIA and Lockheed Martin are partnering to build an advanced AI and digital twin-enabled fire response system to improve fire prediction and suppression efforts. In Omniverse, Lockheed Fire science experts build a physically accurate digital twin of wildfire-prone geography. Then, test their AI model trained on real-world wildfire data. Omniverse's real-time physics technologies enables the experts to realistically simulate variables like wind, humidity, and terrain to optimize the model's accuracy. while the RTX acceleration allows them to interactively study fire behavior in real time. The new AI lab will become a center for real-time wildfire intelligence to support fire responders around the world.
Yeah, you will see more of this. Lockheed has almost 9 sessions. Last year, last GDC, they had only 1 session because they just started on their Omniverse journey. Now they have up to, I think it's 9 or 11 sessions. So you could look into how much they have moved across, right? So it's not just single, because your imagination is the limit on what you can do. So that's what I'd say.
In Omniverse.
And here is an example of another one. So this is something I like really a lot. Why? Because you can say 5 years ago, when I was in another neighboring island chain, very close to you, or not very close, further away from you guys. So they wanted to simulate exactly the same thing, a 5G propagation, network propagation. And so that, so that they optimize the placement of these antennae, right? Because it costs money and ensuring they have best signal and so on. So, but again, doing it in a city scale was not possible at all, because the physics simply was not, or though the physics were there, the compute was not there, because you could not really scale it out so bad. The max you could do was a small building, and inside that a single room, or a little bit you could do manually, and then you have to make reduced order models and so on. But here, I really love this primarily for that, because there is a solution for a problem that I said it was not possible a few years ago.
In Omniverse,
and the reason
Ericsson
why it
builds
is possible
models
is
that are
because
physically accurate down to the
RTX
materials of the
technology and
buildings,
MDL, where
vegetation,
you're able
and
to
foliage.
represent the
Then,
materials
wireless
accurately.
network
The
components
buildings
are added,
are made of
including the
concrete.
precise location,
Then you have
height,
concrete,
and antenna
you have
pattern
wood,
of each
you have
transmitter.
glass, all these
Ericsson built a
materials,
custom
right?
Omniverse
On the left side, you can see it.
enabling
I
them
will
to
not talk
integrate
right now.
radio propagation data and leverage Omniverse's RTX accelerated ray tracing to quickly visualize and calculate the quality of the signal at every point in the city. Because Omniverse materials are physically accurate, the intensity of reflections are precisely determined. Antenna beamforming and signal paths can be accurately simulated and visualized. In the simulations, the lobes signify transmitter antenna beamforming, and the straight lines are signal paths. The colors of the signal paths denote strength in decibels and data throughput. From blue is the weakest to red is the strongest. Visualization is a critical capability for Ericsson. With Omniverse VR, network engineers can virtually explore any part of the model, teleporting to any location, anywhere in the world, at 1-to-1 scale. As they tune the network for optimal performance or identify path disruptions, they can literally see the effects of their adjustments in real time, things which aren't visible in real life. In Omniverse, Ericsson can perform true-to-reality remote simulation of entire 5G networks, enabling them to design more efficient and reliable networks, conduct remote field trials, and speed up deployments.
Yeah, see that what was not possible a few years ago is now absolutely, it's just a matter of scale. I mean, people who want to deploy it, and that's something pretty interesting. And this as well is very interesting to me, because why I spent a large amount of my life or my career doing physics simulation. And especially in these contexts, right, when you're trying to create digital twins of either of a huge plants and so on, there are many different kinds of analysis. I know there are a lot of professors here, deans and so on, finite element analysis using CAE, CFD and all of it, right? So all of these are very, very time consuming. So I mean, I can do this. Say if I just want to say, if my input, if I change the pressure, what will be my output? I can do that once, because probably if I hit the run, it takes analysis takes around sometimes a few hours to days to weeks, right? And then I get the result. But yes, for a digital twin, you can't really wait. You can't just have that much time. A digital twin is something, hey, what if I change this, what is going to be? Because you need to make some get some insights and have some points of action real time or near real time, as I say. Because that is when you can really make decisions and help it improve. Hey, if the flow is low, if the flow rate is less, how will it impact the temperature and the performance? So will it cause any downtime, or will it cause a failure of my components and so on? So in this context, here they were able to speed up some things that used to take days or weeks to fraction of seconds. Okay, this is as well a different piece of technology that is used in conjunction with Omniverse to create efficient digital twins. Looks pretty real, actually, if you look at it.
This massive heat recovery steam generator uses hot gas exhaust to convert water in the pipes into steam for the turbines. Predicting corrosion to avoid downtime is challenging. Reduced order models aren't extremely accurate, and full simulation takes expertise and time. Siemens Energy is developing a digital twin with NVIDIA Modulus for the multi-phase turbulent flow. With point cloud data to train a physics-based AI model, they can infer high-fidelity flow shown by the streamlines in seconds. This could reduce downtime by 70%, saving the industry $1.7 billion a year.
Yeah, that's a huge amount of saving, $1.7 billion a year. That's huge, right? So, but again, yeah, you're able to predict and prevent failures. What does that mean? Essentially, more returns, more quality of life. And yes, especially if you say, for example, this is creating energy and then you're servicing it to the hospitals and so on, you're saving lives as well. So for me, everything that, and the foundation for this is called as something called as Omnivores, which is an SDK or a framework, right, to solve Newtonian physics. So, and this is very widely used to create these surrogate models and so on. And using this, you can really speed up some of the simulations by a factors, actually, multifolds, 10,000 to 100,000 times. And I think this is an extremely important endeavor that we are taking up. So this is called as the Earth 2, together with many other organizations, right? We're using, everything's done in Omniverse here as well. And then, yeah, we are looking at, I mean, of course, the modeling and all of it would be ready by probably in a couple of years. And then, yeah, the whole digital twin will be fully running by, I think, towards 2027, yes. And then, yeah, you can see we talked about one is the scale running 20,000 GPU supercomputer. So, yeah, the scale is there. Having real RTX is also there because that is what will help you simulate and make these changes in real time and see the what if effects. And then, of course, the underlying is the USD for all of it. So, and then why is this needed actually? Because this will help people understand, or the scientists understand, what if changes and what if the temperature or an ice cap melts, how is that affecting the overall the climate of this Earth? Or if there, I mean, it helps you create these what if scenarios, and then you can either take mitigative actions, corrective actions, and then help create a better life, if we would call it. And of course, this model would essentially cover a whole lot of data that will be streaming in, because a live digital twin has, because it's living and breathing, that is, it is getting in data, it is using that data to make decisions, and then it gives out some output, and that is again used as an input. So it is living, right? It's not a static model, just like your CAD model, which is it's as well a digital twin, but again, it's static. There's nothing happening. If you create a CAD model of something with nothing going into it, it's just a static digital twin. And those are many, but a live digital twin needs to have these sensor data streaming into it. And you have, for this Earth 2, what we're looking at is getting in the data from multiple sources: satellite, ocean data, ecosystems, as well as atmospheric data, to create all of this, right? And then you use the modulars to run thousands, I mean, all of these different simulations. And what if the ocean current changes, the temperature changes, and so on, you're able to predict it. And this will help us predict wind energy forecasting, right? Why is that? Renewable energies. People don't want to use nuclear. People don't want to use fossil fuel. I mean, we have seen what happens when there's a war right now, and then the oil prices have increased so much. So yeah, and then of course it's not good for the planet as well, right? For the kids and so on that are going to come into the world. And then the key thing is as well prediction of all of these extreme weather, what's happening and what's going to happen. And it's not just prediction. With the prediction comes in mitigation. So what happens if there is a flood? Say, hey, what happens if the flood is in this area, and then if it rains some more, what exactly is going to happen? So it helps you. I mean, of course, this is coming to a localized level, but when you talk about Earth, it's much more on a planetary scale, right? But yeah, if you are able to do in such a wide scale, you can as well do it into a much smaller scale using the same technology. And I'm sure a lot of you, the professors here, would already be using some of these CFDs and so on. This is again a ParaView kit connector, essentially looking at external aerodynamics or internal thermal flows on all of it. And then, yeah, now how many of you have thought that this is possible? Just moving it to understand what is the drag and what is the drag coefficient or a lift coefficient of the efficiency of these vehicles, right? Electrical, especially with electrical vehicles and so on. So you're looking at maximizing these efficiencies. And I love this because this is, you're talking about huge swaths of data, right? It could be oceanographic data. Here you're talking about tornado because tornadoes are much more common in the US, but not so much in our region, our part of the world. But here we could look at oceanographic currents, or because they're huge, depends on how you depict them, right? Or it could be galactic oceanographic data, or spatial data, or galactic data, which could be huge petabytes of data, right? And visualizing it in real time, and to make sense of it, being able to change the parameters to see and understand what exactly is happening is very, very important.
Since the 1970s, climate researchers have been studying supercell thunderstorms, the atmospheric phenomena which produce the world's most violent and dangerous tornadoes. These storms are incredibly dynamic and complex. Producing accurate simulations of tornadoes can take days or even weeks, resulting in terabytes of data that researchers must comb through. Currently, exploring that data is a slow, cumbersome, non-interactive process. It may take hours to render a new visualization. Using an NVIDIA DGX A100 and NVIDIA Index, scientists are now able to do the same volumetric visualizations in real time. The simulation you are watching now, and is running at 10 frames per second, is a visualization of a simulation done by Professor Lee Orff of a massive 2011 storm in Oklahoma. This is not a recreation of what happened. It was mathematically derived, starting with just the initial conditions just before the tornado formed. This simulation is comprised of 250 billion grid points, with each point having over a dozen attributes, including rain, hail, pressure, and wind speed. The sequence we are looking at here shows 6,000 simulation steps of Professor Orff's entire tornado simulation, which is of a simulation. If simulation and reality don't match, the models must be corrected. Here, NVIDIA iRay, a GPU-based path tracer that renders physically correct light transport, is coupled with NVIDIA Index volume data to power this visualization. We can clearly see the tornado's funnel touching the ground, right? As well as analyze details like the cloud-water ratio and rain, represented by the blue-gray pores. Finally, let's talk about collaboration, a critical part of research. With Omniverse, NVIDIA's virtual 3D collaboration and simulation platform, team members in different locations can view and interact with this complex dataset in real time, an ability unheard of in scientific visualization today. Here, one collaborator in Berlin is showing their findings, interactively changing the color maps to highlight certain attributes in Index to a reviewer, and supporting collaborator in the US. Both are seeing the visualization in Omniverse update in real time. With this new end-to-end workflow, including NVIDIA Index, iRay, and Omniverse,
make these
all
changes
accelerated by NVIDIA
and
GPUs,
visualize it in real time,
climate scientists have a new arsenal of tools
the basic
to
strength
help
of what we're trying
democratize
to achieve,
true,
right? Because we call
real-time
Omniverse as a
visualization to help them
platform
solve the
for
mysteries of the world's most violent
collaboration
tornadoes.
and simulation. And simulation for us is all of this, physics-based, okay? And then finally, okay, sorry, let me pause this, because I saw in one of the earlier, I think it was the national anthem that was played, right? Or Mardaka, Mardaka, and so on, right? So that was the national anthem, I'm guessing. So yeah, in that actually you had people that did the mocap suite, right? They wore mocap motion capture suite, and then they were dancing and so on, right? Now we have something within Omniverse called as, of course, everything we try to do fuses AI with all of the visualization that we say, right? So this has something called as AI pose estimation. So here, so this will, I mean, with just your phones or your cameras or your tablets, you're able to do what exactly this $30,000 suit is doing. So here, yeah, and you can map it to an character as you see it here down here. So we have seen its use cases come across from physics-based digital twins, from extremely large scale, the planetary scale, to a small focused area like factories, to a small, even much smaller than that, like looking at a steam turbine generator, a single components and so on. And now you look at in this one for an media and entertainment. I see a guy here, and then you're just using your phones. So as you move across, the AI pose estimates how you're going to move, and then you can map it down to a character as you see on the astronaut here. And then, yeah, you just, and the depth perception, you'll be using your tablet, or every iPad or whatever has this depth perception, Samsung tabs and so on, that uses that, which acts as AR. And then, yeah, bingo, that's where you lie. And then you're able to recreate such a complex or $1,000 or $10,000 suit complex scenarios just with just your phones and so on. And especially this is important because a lot of people are creating these avatars, as we call it, right? Or it could be animals or whatever it is when you're trying to create as a creator. So yeah, all of this comes into play there. And then the virtual production, as we call it, it's all done using some of these technologies that we see across. Yeah, for those of you, a sort of a Bollywood dance, I guess. But yeah, I mean, this one down to it. So, but again, yeah, these all complex movements and all of it can essentially be done with using everything that you have at home. You don't really need to invest thousands of dollars there. And then finally, I think this is something where we see a realistic value when we are creating these characters that have intelligence, right? So you can deploy these down from anywhere. There is wherever there's a customer, at least at this point of time, I see it as customer services, customer service, banks, hospitals, education, teaching, because there are folks that are creating these virtual twins of universities. And I think the first place that would disrupt using this virtual world is going to be universities, because if I want to attend a university in Bandung Institute of Technology, I don't have to go there. But if I'm create a virtual university, I can just use a headset and then I can teleport into that world. Or if you want to go study in Stanford, you don't have to go travel thousands of miles, because that as well is going to happen in a very, very short time. And thanks to some of these, of course, thanks to Toy Jensen, just listen to this. I think it's a pretty interesting conversation, because it's not a question and answer that has been tabulated, but this is more of language processing and all of it, and recommendation as well.
Hi. Hello. Hello, Toy Jensen.
Hi, please ask me anything.
What are the greatest threats of climate change?
The greatest threats of climate change are the effects on human health, food security, water supplies, and the environment.
How do astronomers look for exoplanets?
Most exoplanets are found via the transit method. That was the case for the TRAPPIST-1 planets.
Tell me more about that method.
The transit method is when a planet passes in front of its star. The amount of light blocked tells astronomers the size of the planet. The duration of the transit tells astronomers the orbital period of the planet.
What telescopes use that method?
The Kepler Space Telescope used the transit method to find thousands of exoplanets.
I've heard about a satellite called TESS that is used to find planets. How does it work?
TESS is a space telescope that looks for transits.
What roles do proteins play in our cells?
Proteins are the building blocks of the body. They are the basic materials from which all living things are made. They are needed for the structure, function, and regulation of the body's tissues and organs.
How do they work?
Proteins are made up of amino acids. Amino acids are the basic building blocks of proteins. There are 20 different amino acids that link together in different combinations to form different proteins.
How do they catalyze chemical reactions?
Proteins are biological catalysts. Catalysts are substances that speed up the rate of a chemical reaction without being consumed by the reaction. Enzymes are proteins that catalyze and increase the rate of biochemical reactions in the body.
Thank you. Goodbye.
Sure, anytime.
Yeah, I think this will be more and more useful because, yeah, you don't know, how many, because you'll have thousands of people interacting, right? Say if I go to a bank or if I go to a hospital or if I go even to a shop, a virtual shop, right? As we call it, because everything will be in the virtual world. It's going to come in sooner or later. And yeah, and so, yeah, you don't know if I go in there, how do you know what I will ask that character that is there, the avatar that is hanging in there? There is no way that you can predict. Yeah, it's just like Alexa or Siri that matter, right? So yeah, but again, all of these Jarvis, Riva, all of these SDKs for NLP and training and language, text to speech, speech to text, all of these are free, available on the NGC. So for you guys to download and start using it. Yes, so all of this is available, and that is what this is a game changer because it's a confluence of two different technologies: visualization and AI. And yeah, and that is where we'll see a lot of other advances will happening in the future as well. And yeah, I think this is as well another piece of a nice technology where you might ask me, where does this come in? This could be in restaurants, it could be in automotive vehicles and so on, because this is as well very key where, yeah, it's a sort of recommendation engine, because yes, I thought somebody was talking about it as well in the earlier. So we had some researchers doing it. So yeah, you could collaborate with the guys, the creators that are doing some of these. So it could be your, because EVs or all of it, right? Or any of these newer gadgets and so on, wherever there is a sort of customer service or where you have to offer, or education, even in schools, you have this kiosk where I can just go in virtually or even physically when it's there, and I can just ask, hey, what classes do I have to attend today? Or I mean, of course, yeah, assuming there is some sort of identification that happens because there's a camera there to the side, and then it can tell me what options I have and so on. So how can I schedule it? So there are many ways that we can think of, and I think that is one of the reasons why I have put it here. So it's already recognized who's there.
Welcome to Shannon's Cafe. How can I help you?
Can I have a cheeseburger with a side of onion rings, please?
Would you be interested in our popular toppings for cheeseburger like bacon and fried onions?
Yeah, let's do it.
Instead of
added cheeseburger with bacon and fried onions.
Yeah, instead of the food, replace that with something.
What protein options do you have?
Schools or classes and so on, right? It could be anything.
We have multiple options. I recommend the double protein burger. Would you like that?
Do you have any vegetarian options?
I can get you a black bean patty instead. Would you like that?
Sure.
Okay, I have added double protein burger with. We have market salad, Cobb salad, two options.
Yeah, as you can see here, there are many different use cases, right?
Okay.
And that's it. Yep, you had seen all of these different ways of creating different technologies come into picture. And finally, now there is also some, I mean, of course, there is no virtual world that is complete without sort of immersive technologies, as we call it. And especially with the advent of these high power compute, right? People, and then also because of the geographical nature of how Indonesia or different places are poised or placed, right? Say people across different places want to experience this. So it could be through 5G, or it could be through satellite data centers spread across the country and so on, right? So as you can see, yeah, this is as well, there is a part of technology within Omniverse called as Cloud XR. So where you can literally stream extremely high fidelity model. You could use it for collaboration. I think, yeah, so yeah, again, yeah, again, a call out. Yeah, go ahead and then, yeah, attend the GDC. I think whether you would see a lot more. Just a moment, let me turn off the video here because audio there.
Streaming solution for virtual reality and augmented reality. Combined with 5G through Aerial, Cloud XR provides a powerful edge computing platform for extended reality. This application, Autodesk VRED, is widely used in the automotive industry for collaborative visualization of designs, including in VR, However, in the past, VR
I think
and
the
AR
critical thing is there
required
is
some
really no
serious
car there, but you
compromises.
feel that there is a car.
Users had to be tethered by a cable
And then, yeah, it doesn't have
to
to
a
be tethered
workstation,
anymore, right? With the 5G
limiting
and so
freedom
on.
of movement
So you can just use
and making it
a,
difficult
I
to
mean,
collaborate
untethered
with
sets.
stakeholders in other
It's
locations.
boundless.
Now, with Cloud XR over 5G, it's possible to stream high-quality VR to
Or even
tetherless
Wi-Fi 6, right?
headsets,
If you're looking at a
such as the
captive center
Oculus
and
Quest
so on.
shown here. Users can be virtually anywhere. With Cloud XR, augmented reality also becomes possible. Here, VRED is streaming the same content to a 5G mobile phone, so a stakeholder can view design changes
That's
in
essentially an
augmented
AR, right?
reality
What we see
on
across.
location. While a designer makes changes such as switching materials, the AR user can view the changes in the real-world environment. And finally, VRED provides streaming over 5G.
As we see, right? Yeah, if you have any questions, please type in the chat windows, the Q&A. I'll try to answer them post the session. So here is another example. Again, it's for cloud VR, again, as we call it, right? It's a collaboration where we talk about people collaborating on something. So you can see how fast it happens, and it's seamless, right? Essentially, it doesn't matter wherever you are. All you need is an untethered set together or different places. Yeah, collaborate on a single scenario. I mean, of course, the experiences matter. Yeah, is that, I mean, of course, creating people, because yeah, right now, if I want to create some of these experiences, I have to hire people from Europe or elsewhere. And that is also one of the key things that we need to train our students as well on these technologies. Yep, and then finally, yes, we come to this. Then we also look at, we have looked at VR, AR, and then looks at mixed reality, MR, that completes this whole set, right? Here is some people that have used it for training. And it's important actually, yeah, because we see that more. These are some of the low-hanging fruits where people will literally use in some of these complex scenarios, be it for aircraft repair or for that matter, oil and gas scenario or geothermal, or it could be even any scenarios that sometimes is hard to replicate as well, right? Or people under stress that are performing certain jobs and all of it. So you could get them to train in these multiple scenarios, and then yeah, when they go out into the field, they are literally able to perform exactly as they're supposed to. And this is more immersive when we are trying to teach students. So that as well is very important. And finally, yeah, we have seen the digital twins. And then finally, another piece that is very, very critical to all of this to happen is being able to collaborate and being able to collaborate in real time. And this is the whole value of the platform here as well, as we say it. So if you can look at it here in this context, we are talking about a typical process, a design process or a scene creation process happens in a serial fashion. That is, I finish one task and then I export it and pass it to another person that does, okay, say for example, Maya to Max, 3DX Max to Unreal to Adobe. And then again, yeah, if it's not satisfactory, it loops back again. It's more of a serial process. What happens essentially is nobody knows what the other person is doing. It takes away too much of time trying to do all of this. So if there is an Omniverse is what really changes all of it, allowing parallel processing, or rather enabling all these tasks to happen parallelly, so that all these changes you could see it in real time. And that's where we call it as real-time collaboration. Just a moment, give me a minute. Not this. Okay.
As an animator, designer, or engineer, you can bring the power of collaboration between applications and people to your workflow with NVIDIA Omniverse. Before Omniverse, working on a project using multiple applications required exporting and importing from one format to another, often causing creators to lose information and compatibility along
If you're
the way.
in civil
And
engineering
adding more people
or
into a
media
workflow was a
entertainment, you know
nightmare
this
of
problem
updates
there.
and file merges. The Omniverse platform enables true real-time collaboration for individuals and teams working between multiple apps and working across geographies. Omniverse brings the ability to seamlessly sync file changes
Many different tool sets, not just these. These are just for showing there are more than 40 different tool sets that you could use for collaboration.
Whether working alone or together, Omniverse creates an infinite number of connections, from app to app, person to person, or office to office. Get Omniverse now and experience the future of collaboration for yourself.
And then, yeah, here is a live example where people are using Unreal Engine, Substance, and then Omniverse View as well. So 3 different people. And as you can see here, anytime they're making changes, as they make changes to this wall in the middle screen, you can see it happening here. As they make changes to the table here onto the bottom left corner, you can see it happening there. So all of these changes are happening real time, right? And parallelly, you make in another window, it gets all these gets updated. So this is called as real-time collaboration. This was not possible before the advent of Omniverse. That's what I can say. And what makes this possible? The key principle or the key technology that allows all of this to happen is called as USD. Which is a basic format in which all of your scenes or your whole database is stored. And this is from Pixar. Yeah, I mean, most of you or all of you would know who Pixar is. And of course, the Toy Story or the amazing, beautiful movies that we see, right? All the animation movies. And it's a very widely accepted format, right? And then there is a concept inside that called as layering that essentially helps you seamlessly, helps with this for real-time collaboration, because you only export these deltas or changes that happen in these layers. And so, yeah, this is pretty extensible. It's flexible. So, yeah, as you can see, a lot of them because it's open source. So, and I think this is where the key lies, becoming an industry standard format for all these different industries: AEC, M&E, robotics, autonomous vehicles, and so on, and even product design and manufacturing, as we say. And the same thing, what we had seen earlier, on your left side, you have people that are using multiple tool sets. And all of these guys here, all of these people here interact and connect to the nucleus, which is much more than a database. Okay, it's not just a database. It's called as a collaboration engine. And on top of that, and all of this happens through USD. So though you create something in Revit, you experiment, or when you are connecting it to when you have connected automatically to the nucleus, all these changes happen and it automatically converts into USD and is stored in the nucleus, right? Okay, sorry, I thought I had this video. Okay, okay, and then and how does this change happen actually? And then you can consume this using any different tool sets, or be it either as a tablet or on the phone or on your laptops, or even using AR and VR. So here what you see is a scene graph. Say I'm using Maya here, right? Application 1 is Maya. So anytime I make a change in the scene graph, that is change in the color, or it could be coordinates, right? I move something. This gets updated using a plugin to this USD library, which is transmitted to the nucleus. And the nucleus blasts it out to all the other applications that are connected to it of this change that happens. And then it gets updated, and then it passes on to the content library, to the USD, and then updates in the second scene graph in the second application. As you can see, so this sort of small change that has happened is transmitted all across to all these different applications that are connected. And that is how you would, all of these different connectors, as we call it, will work in tandem with each other. And you might say, hey, Raghu, what are the different tool sets I can use for connecting to Omniverse? What should I use? Should I use any specific? No, that's what we say. Yeah, you keep using whatever you're using right now to create these virtual worlds. And as you see here, some of these are generally available, and some of these are still in beta, and a lot more are still under testing. So yeah, and of course, and then there are generic formats, say like step file, IGS file, and then we also have the E57 point cloud format, right? And then yeah, these are some of the generic formats you would see in at least 70% of the cases. And you might say, hey, yeah, my connectors are not here. So there are two options again here. Say, for example, you don't have this. So you are very well, because Omniverse provides you with the flexibility to create your own connector. So you could do that, right? So you could create your own connector. Or you could convert it into one of these common formats and then bring it inside. So these are the two ways that you can essentially communicate. Oh, well, it's stuck somewhere, sorry. Just a moment, it's stuck. I'm sorry, just a moment, but it looks like my PowerPoint has stuck. Okay. And what is Nucleus? Nucleus is not just a database. It is much more than that, actually. So here, yeah, you can actually publish modifications to these digital assets and virtual worlds, as we call it, right? And then you can subscribe these changes. You create microservices on top of it. You create your connectors, and that is where they connect or transmit these changes to it. And yeah, you can install this Nucleus, which is basically, as you say, a repository of all of these data, right? On either workstations or in a on your own data center or into your private cloud. So there are multiple ways of using all of this, as we call it. And here is another example here. Somebody, WPP is one of the largest advertising agency in the world. And perhaps, yeah, they use a lot of these different tool sets like Adobe or Maya and all of it for advertising, right? Here, they were able to recreate because obviously because of the pandemic, and then of course people that are interested in sustainability, they're almost embracing all of these different technologies called as virtual production and all of it. So yeah, they were able to create an extremely high fidelity model using Omniverse, and then yeah, recreate. They didn't have to move anywhere. They were just doing it staying within England itself.
WPP is the largest marketing services organization on the planet, and because of that, we're also one of the largest production companies in the world. That is a major carbon hotspot for us. We've partnered with NVIDIA to capture locations virtually and bring them to life in studios with Omniverse. Over 10 billion points are turned into a giant mesh in Omniverse. For the first time, we can shoot locations virtually that are as real as the actual places themselves. Omniverse also changes the way we make work. A collaborative platform that means multiple artists at multiple points in the pipeline in multiple parts of the world can collaborate on a single scene. Real-time CGI and sustainable studios, collaboration with Omniverse is the future of film at WPP.
Yeah, so all of you that are into the media and creative worlds, right? Just go ahead and try it. It's an amazing piece of technology down there. And then, of course, all of this is possible primarily because of the physics, right? Being able to, yeah, it does not behave as a Lego blocks, or it does not behave as Minecraft. Because, yeah, or a video game has many non-physics based intuitions. But yeah, because if you are creating a virtual world, you need to ensure that whatever you're creating follows this the same laws that the physical world behaves, right? So it is the Newton laws. So if a glass falls down, it shouldn't rebound. It's not rubber. It has to break. Or when you're holding a fabric is supposed to conform a shape to the object that it's falling on top. And many things are physics. So Omniverse is built in with all of these physics. So rigid body, soft body, and vehicle dynamics, and so on, blast and fracture, or be it cloud and fire as well, right? Fluids for smoke and fire there. And when we also look at it, all of this we have said, and then finally, when we are also coming down to training a lot of this synthetic data, training our robots or training our autonomous vehicles. Yeah, there is, I mean, yeah, there are two ways to essentially create an efficient or a robust algorithm, right? You train it with huge amounts of data. You can take a car, you can run it 24 hours a day and so on, but still, yeah, the amount of data and the number of scenarios that you would have trained for it would be still limited, right? Yeah, and then say, for example, you want to create a unique scenario that is very common in Indonesia. Say, I don't know, I'm just saying, say rain and sun happening at the same time at 5 o'clock with certain visibility and so on. So this is not, you can't just get that scenario. You just have to wait for it. But with synthetic data, you can recreate all of these different what if scenarios, and you can create thousands of these different combinations to train your models and make them robust there. And of course, these, and what else you can say, hey, how do I go get started? I mean, of course, there are many different applications that are already part of Omniverse. The two things that will help you create is, of course, create and view, NVIDIA Omniverse create and view. So that is to create your build, any sort of these technical worlds and so on, or view, that is basically for viewing all of these different things. And Omniverse code is what I was talking to you about. You could use these snippets to actually create some of these connectors, as we call it. And of course, many other different things. These are audio to face is another application that is just written in Python. You can use these snippets to recreate these microservices, as we call it, right? So yeah, you can map my speech to an avatar. So, and then, yeah, it will exactly state, or you can listen to it exactly as if I was talking. The avatar would be talking, but it would be using my voice and the movement of my mouth as well. All of these facial features would comply with however my jaws and muscle moves, right? So that is something called as audio to face. There are many others that are available as part of this, and some of these are under beta, some of them are under general availability. So yeah, you could try them, and then all of these are for free. And here is an example there, the audio to face. So where you just capture an audio clip and you can map it to a 3D 3D mesh or a 3D object. So here, yeah, you can map it to a rhinoceros or a monkey or whatever it is. And code as well is an IDE. It's so you can create these applications and microservices, and then you could use that. So yes, yeah, earlier when I talked about the connector, right? You mentioned, yeah, what if you don't have that connector? Perhaps with the Omniverse code, or it is a proprietary data set that you have. So you could use all of this to create these different applications or microservices, as we say. And the key thing is, of course, building blocks. So it's a modularity, right? It's very important for customizing it and then using different combinations rather than one big application. If you build it in blocks, it's easy to debug. It's easy to use certain parts and recreate. And then, of course, everybody knows Python, literally almost, as we say. And yep. So, and then you can use or leverage all of these different NVIDIA technologies that are already available, right? Like AI, real-time ray tracing, and all of it, and then integrate it into these applications, as we say. You might say, Raghu, hey, how do I get started? So the one way, the first thing is, okay, post this. I think I'll share this this whole slide deck with you guys as well. So yeah, just go ahead, explore, just log into the website, click it on. You can see here, download Omniverse beta, and then you can play around with it, install it. And then, yeah, if you are if you are interested in code development and so on, or creating some intelligent avatar, or I don't know what your ideas are, but yeah, you could use that to as well develop on Omniverse here. Or for that, and then yeah, there is documentations, tutorials, and webinars. A lot of them will help you. The documentation is pretty nice, amazing, and there are YouTube channels and tutorials that are available to get you started. Say, how do I import this? How do I create this, and so on, right? And there are public forums actually, both on NVIDIA website and as well as on the Discord server. So there's a Discord server for that. So you could just log in, and then yeah, you can create it, and then just try exploring, as I would say. And for the other folks that are into developing, right? So you could take getting into, I mean, just go ahead and be part of this developer network, as we call it. So where you could get some access to some of these technologies for training. I mean, of course, we are building it on. So yeah, there are research papers that are available and so on. So there are hackathons and a lot of it that you could take part and create applications on top of Omniverse. Yep. So final is, I think this is my last or second last slide here, essentially looking at, yeah, creating your own virtual world or use case. So it could be an university, it could be a department, it could be a lab, or whatever it is, right? So you could start off from somewhere, or it could be even your own department where I say, hey, how do I create? I want to use these creative workflows or collaboration with all my design school, right? Or say, and so on. Or it could be, I want to create a digital twin of this lab, or it could be for the whole of university and so on. So yeah, just go ahead and plug in your use case, and then yeah, you know who to reach out to if you have any questions there, and whatever help and support you need. So finally, what I would want to do is, before winding out this presentation, I'm going to do is show you a last video here that shows all of this confluence of these different technologies that we have. So again, yeah, this is our flagship video, which is from BMW. Why? Because BMW, 99% of their cars are custom built. So yeah, you got to ensure that each line, anytime you want to make a change to any of these, you have to validate it. And of course, you have mobile robots and fixed robots. You've got to train them and ensure, of course, in the Western countries, human ergonomics is taken into account. And of course, training autonomous vehicles, as you see here, using different sensors, or be it VR or AR, visualization of things to help either impress your clients or get things done faster. Virtual productions, digital twins, using modulars, or the whole cities, as we call it, or whatever be the application, as you say, or recreating just for museums, if for that matter. You create museums, virtual museum for people to consume it. Fire or flood simulations. Vehicle trainings, actually, AGVs or autonomous vehicles. Or just create funny worlds. And of course, you could use synthetic data to train IVA. Or just create your own beautiful worlds as they look. And perhaps, who knows, you can sell it as an NFT. And for those that are into animation and video game creation as well. Or the smarter guys who are into physics simulation. Yeah, you could use all of that. Your imagination is the limit. There. Okay, with that, I think I've almost come to the end of my presentation. If I may share, finally, yep. With that said, yeah, I'm almost at the end of my presentation. So if you want to know more about what the guys across the top-notch companies across the world are doing for either the virtual worlds or Omniverse, using Omniverse and so on, or at the confluence of AI and visualization, yeah, just log into the GDC, where you can have thousands of, or at least hundreds of talks on different subjects that might be of interest to you. And if there is a specific set of a topic that is of interest, reach out to me separately. I would be very happy to share a set of talks down with you. My email address is rganti@nvidia.com. Okay, yes, I could just type it here as well. So yeah, if that's okay, it's a little bit complex here. Okay, I could do that here. Yeah, that's my email address. So for those of you that look at it, So Rganti, RGANTI @nvidia.com. And then, yeah, just go ahead and log in there. And I look forward to seeing you all in the Omniverse there. With that said, I have come to my conclusion of my presentation. And then if there are any questions.
Okay, thank you, Raghu, for the presentation. It's a lot of information and it's really interesting. A lot of insights for sure. So for the question and answer questions, actually, we have quite a few of questions. So I think we can start from the first question. It's from Ninda. So NVIDIA Omniverse has a very interesting virtual display. I want to ask how the Omniverse can be implemented in education.
Okay. I mean, for education, there are plenty of things, right? As you see, creation. One is what in which department or what is your use case? What are you trying to solve in this virtual world? So, and let me give you an example. So, there is a university in the US that currently has around 80,000 students on its campus, right? I mean, 80,000 students is big. But by 2030, in another 8 years, they want to increase it to 100 million students, 100 million. 80,000 to 100 million, which is almost like around 35 to 40% of the US population. So will all of these students be from the US? No, all of them will be from different parts of the world. And will can 100 million people, if there are 100 million people, students in one campus, just imagine what the other universities would do. I mean, it's not possible to sustain that. There's no way that it will be only through the virtual world. So people are creating virtual campuses. So for people to consume, that would be one part of it. And the second is creation of these. So for example, I'm teaching somebody to, I don't know, design or some sort of a design, right? A building design. So in that context, so yeah, now if I tell you change the color to blue, or change this line, add this line. So it is so bland, right? It's 2D, it's voice. There's nothing else down there. But what if I am able to, we are able to collaborate right now on particularly say a car or a building. As you do it, I am able to explain it down to you. Hey, change this exactly to this color. And then you see it and happening in real time, how much of value that provides. The third part is, of course, AR and VR, which of course, do they add a lot of value? Yes, they do. But again, will everybody get access to it? Because there are limitations as well. But that is as well a very good scene or way for people to engage with students and then get them interested in particular subjects and so on. So there are a lot of, and then of course, if your university already has an AI practice, right? Then yeah, you saw these different applications of avatars and whatever. So you could start off with that, because end of the day, I mean, the university, the industry wants these applications, people who can use these applications, create XR applications or training materials, simulations and all of it. But students, if they're not trained, how will they get it? And where will they get all of this? This is from universities again. So this is one way of keeping churning, because I work with quite a few of the universities and higher education institutes here in Singapore as well. And that is the way to go, because if universities embrace it, then the industry will be open, because industry wants, but yeah, nobody supplies it now. So the only supply is available is in the Europe or US, and that's where we have to get it from. So yeah, not locally. So I think that is one way you could get started, start identifying use cases, and then yeah, get started there. And happy to assist you there as well. Yeah, if you can talk to the Epsindo team, and we are always there to assist you, help you brainstorm and get these kind of sort of use cases. Does that answer the question? Yes.
Yeah, thank you, Raghu. So actually that question, we have a lot of questions actually asking about how it can be implemented in education. So I'm sure that's helpful. And then the next question is from Pak Surya. So maybe the question is, I think, what is the requirement to use NVIDIA Omniverse? Because it needs RTX, so can we use it in DGX A100? Can we use NVIDIA Omniverse on that application?
No, okay. Omniverse, because this is visualization. Yeah. You're not. You don't want to use DGX for visualization because DGX is primarily for calculations, right? Say, for example, in this context, say you want to develop a autonomous vehicle or robots, right? Say because that will save lives or improve the productivity or whatever it is. So for that, you need training data, and the training data is through AI. That is, DGX creates it. But anytime you want to visualize it, it is not DGX, it is RTX. So it's a different technology, right? Visualization goes in there. So yeah, you could use a combination depending on the use case that you're trying to solve, but primarily it is a different. So anytime you have these Ampere series, as we call it, right? The professional series of GPUs that I shared earlier. So that is the I mean, of course, A40 or A6000s and so on, right? A5000 and A6000s. So these are what you would need for creating these worlds. Say when you're trying to create using Autodesk or any of these applications, you cannot do that using a DGX, primarily because it has no visual output there. But yeah, you can use a combination. But yeah, you can just, A100 cannot be just used for Omniverse. It's not created for that. Yes.
Thank you. So I think the next question is kind of a line on our previous question, because the question is what kind of GPU model that we need to run in this Omniverse app? Do we need to use the latest CUDA version to use this Omniverse? And how the Omniverse can help our experience from the university? I think some of that we have answered it already.
Yeah, I think going for the professional series, as I say, right? I mean, the least is, I mean, A4000s, A5000s, and A6000s, and A40s. That is what you should limit to. Or the previous generation of the RTX 6000 and 8000. If you have those as well will run it. I think, yeah, because when you're running all of these professional applications, you would want to use professional GPUs for professional series. So that is what we would say. Yes.
Okay, and then the next question is from Fitria. There are two questions. The first question is, how do you adapt it to the way the affiliation wants to allocate hardware and software spending? As you said, Omniverse Enterprise has a support contract and license fee. And then I think the second question is the same question, like how big is the change that NVIDIA Omniverse can be used in education?
I think I've already answered that, right? The education of this, but again, if the affiliation wants to allocate hardware and software spending, I don't know how do you adapt it. But again, yeah, you work out with the Epsindo team. They are very experienced with that. They can help you. I mean, I don't know if you're talking about OPEX to CAPEX. So I think the Epsindo team is very well versed with all of this. And yeah, we can definitely look into how we can support you down there as well if you're trying to look at it and so on. So I think they're well versed in that. Yes, they should be able to help you out there.
Sounds good. And then the next question, I think it's a similar question again. So how to join using this unique Omniverse for education? What is the requirements?
No, education, I think there is no fund. I mean, of course, apart from the getting in the licenses, I think, yeah, you just need the right hardware. That is the Ampere series GPUs at this point of time. So yeah, go get yourself a few A5000s and A6000s, because you can use the same for multiple users. It's not just just for this. You could use the same for computing as well. Depends on, so yeah, just get these software as well as the hardware, that is A40s or A5s and 6. And yeah, you can get started right away.
Sounds like a good plan. And then the next question coming in from Raihan. So the question is, will the Omniverse be able to connect with other metaverses, and how is the system?
Okay, will Omniverse be able? Okay, depends on your definition of metaverses, right? So yeah, when you see metaverse, we already have. So I mean, I don't like. I mean, I'd use a virtual world. The word called as virtual world because that is what it is. Because the definitions for all of these verses is so vast, right? It's a virtual world. So is there something that already connects it? No, there is nothing. There is no common denominator. So let me give you an example. So yeah, we have these virtual worlds from a very, very long time. Okay, so yeah, is there and of course when I say virtual world, you could say if you're playing video game, Destiny, to say for example Halo, Destiny, all of these are different video games and they are virtual worlds, and Epic, that is Fortnite and all of it, right? So is there a common denominator down there? No, there is nothing. But again, when we are talking about this engineering virtual world, as we call it, what we are trying to build, right? So here we have an Autodesk world. Say, for example, you want to design a car. Now, for that matter, just give me an example of a car, right? So to design a car, you have, you typically use CATIA for creating this, the body in white. And then you use Siemens for perhaps the interiors part of it or the engines and so on, or you use AutoCAD actually and VRED for actually the rendering part of it, and then Adobe for some other things. So these are different worlds, and that is where we are seeing a confluence. Okay, that is one part of it. The second is, of course, the basis for all of this is being able now, as you've seen, all of these communicate using USD as a common denominator. And over a period of time, I think as we go by, we will be adopting a common platform. And I think USD is very well suited. As you see, so many different applications and different industries are able to seamlessly collaborate. Right, using Omniverse, and I think that is a foundation, and that will eventually grow. And you will see that when you especially scan this what do you call the QR code that I've shown across in the next week when we explain it, you'll see some more additions happening to this pool, as we call it, of or the different tool sets that are getting added to our Omniverse. So as you see, it will grow. There is nothing existing at this point of time. It'll take some time for all of this to happen. Yeah, and that is where I see. And then it is not just this virtual world. It will be different universes being able to talk to each other. And the common denominator for it would be USD powered by NVIDIA technology there.
Yeah, so there are a lot of things that can be done for sure.
Yeah,
the next question is the next question is an interesting question regarding the processing of data that can be processed in the NVIDIA Omniverse. How about the detailed specification and performance related to data processing that researchers can use to improve the quality of research and speed up the computational time of data processing?
Okay, that's can you repeat that? That was a little bit hard to comprehend there.
Sure. So regarding the processing of data that can be processed in the NVIDIA Omniverse, how about the detailed specification and performance related to data processing that researchers can use to improve the quality of research and speed up the computational time of data processing? It's rather a long question.
Yeah, I mean, okay, no, yeah, I mean, if you want to use or you want to speed up or yeah, I mean, recreate the data and use it, because the synthetic data is all about it, right? What we're trying to do and help researchers accelerate creating of this data to create better decision models there, or better algorithms, as we call it. So it could be for many different things. It might be depending on the world that you're building. It could be for physics. It could be for media entertainment, where people are creating all of these virtual worlds in a fraction of a second. Because earlier, if I had to create a scene for animation scene or a virtual world scene, it would have taken me such a long time. But at this point of juncture, so you could automate it. There is AI in place, and again, yeah, you could use your own compute, your own. I mean, if you have your own technology that you want to make it a part of it, so you could as well create these microservices and bring it into a pipeline or a workflow, as we call it. So there are ways the researchers as well can speed it up. And then of course, CUDA, port it down into CUDA. And then if you're using a VR application, you can go ahead and use all of this as well, right? So you can use Cloud XR, port your application using Cloud XR SDK, and then you can stream it across to any device virtually anywhere using 5G. So there are ways, definitely yes, how researchers can use and speed up their computational times or improve the computational times using the feedback that Omniverse gives. If that helps anyway, yeah.
Yes. And then the next question is from Nur Ihsan. So the question is, because this Omniverse works in real time, so therefore to work simultaneously with each other in this Omniverse, does it need a very fast internet?
Okay, there are many ways to deploy these Omnivores, right? You could do it locally on a workstation. So yeah, you're all connected on the same network, so you don't really need internet at all if you're on the same network within the same environment. Two is, if you're looking at it from a data center, so yeah, you would be deploying it using VMs. So yeah, a lightweight VM. So you would need some sort of, not a very fast internet, but again, yeah, using that as well. If you're connecting it to a data center, so that's all possible. And the third is, of course, if you're looking at connecting it to a public cloud, because you could even deploy it on a public cloud, right? And then so yeah, depending on the connectivity is there as well. So you would be able to, depends on how good, or because if I'm assume it, all of these guys have pretty decent connectivity. So you don't really need a extremely high or super fast internet. The only time you would need it is when you are doing a VR sessions where you're streaming in large amounts of data, either because you look into latencies and all of it, right? Only in those scenarios. But other than that, I think, we have folks, you don't sometimes need an internet connection at all, or a decent internet connection is more than enough.
Yeah, so it depends on the purpose on how we deploy the Omniverse then.
Yes. So primarily, some local workstation or small user group, you don't need internet. Two, if you're deploying it across the world, then there are ways to mitigate all of this. So because it could be, if you're deploying in a typical use case where you have in Jakarta, Singapore, India, then after that in Middle East and so on, all of people collaborating, there are ways to essentially overcome that sort of logistical issues. But definitely, yes, you don't necessarily have to, but again, it depends on the definition of very fast internet.
Yes, I would agree with that. So the next question is from Nur Udin from Universitas Pembangunan Jaya. The question is, in building the Omniverse, for an example, for demonstrating airflow surrounding the car, do we still need the mathematics equations?
Yes, you still need a CFD because you're teaching it, right, for a particular thing. But again, it can learn fast. So you're not exactly, say, for example, it could be from any other data that is already available, right? So you still need some empirical simulation, that is equations to solve, and then you would need some CFD data, and then using that, you can really train your model.
Okay, so we still have a couple more questions. So the next question is from Universitas Asahan. The question is, how can we apply this technology for the rural people who's living in poverty?
You tell me, what do you want to do for them? And then I can perhaps tell you if the technology will help them. Okay, I mean, how can we help people, right? The first thing is, can you save lives? The first is food, life, and shelter is what we look at. Typically, those are the basic needs. So with the technology here, can I help people to predict where and what will happen? And then can I make their lives better? If there is a fire, can I predict where and how the fire will propagate so that I can send the fire brigades into that location? If there is going to be a flooding, can I predict that? Or if there is going to be heavy rain, can I predict that? So I can save lives, right? Yeah, that's one part of it. And the second part is, of course, education. Now, if I'm able to send or educate these people, right, give them some sort of education, training. It could not be what do you call, it doesn't have to be a university degree, but it could be a vocational. I teach them how to make something. So if I'm able to pass these small courses and so on, so that they can make something, then it makes perfect, you're improving their quality of life as well. So that is something that you should look at. Again, I don't know, because you guys are experts at it, and you know what you're looking at. But again, as you see it, right? So these are some of the ways that we can address these problems, issues that we have, and we are happy to be part. Actually, if you can share some of this, what your plans are, say, hey Raghu, can this help solve some of these? Can we use Omniverse? I can tell you yes or no, why not, yes, if yes, why it would be a perfect solution as well. Just reach out.
Yeah, so we need to know what we want to do, like what is the goal, what is the purpose, then we can somehow come up with what can be done.
I agree.
I would agree as well. A couple more questions. It's from Nanda Septiani from University of Raharja. The question is, why does artificial intelligence impact the workforce, or maybe how does it impact the workforce?
Yeah, I mean, yeah, AI has significant impact, right? Because everything gets done so fast, or even with little human intervention, as we see. We were talking about it. Okay, people say, hey, with the virtual production, I don't know how many of you have seen Disney, right? Disney Plus. There is a series called as Mandalorian, which is all done in virtual production. So on a small room that you could literally do it, or the WPP. So people are not traveling then. If the people don't travel, there's so many lives at stake. People say, yeah, hotels or the tourism industry, and then all the people that live when tourists come. But again, why don't you look at the other side of it, where as you create this technology, right, you need more people that need to have a stronger understanding of these technologies. You are increasing the skill level. As this low-end jobs are going off, the higher-end jobs are coming up, which are well-paying. So we need to train these workforces so that these people who are at the lower end are able to transition out. And that is what. So it's not always a bane, but as you see, so you'll see it impacting significantly. If you're not prepared for this change, then it would be hard to adapt to this. But folks that are open to adapting, because, and that's the reason for this AI nations that we are doing, right? So yeah, keeping it affordable and accessible to everybody in the world. And that is where it comes in. And yeah, so tell me one industry that is not impacted by AI. Virtually, I can't think of anything. Your food to virtually every domain is impacted, and we'll see a lot more automation and a lot of it happening. And as with I mean, and this is going to be unprecedented, right? Because traditional technologies have been a slow growth. As you can see here, it's a smooth curve as it goes. But with AI, essentially, it's always going to be something like a hockey stick. So yeah, whatever happens, it's going to happen at such a fast pace for us to essentially, it'll be hard for us to look, because you can take this virtual worlds, or legislations, or people, you can't comprehend. There are no easy way to comprehend what kind of laws you need in the virtual world, and will the virtual worlds need laws, and so on. When I say LAW, not LOSS, laws. So yeah, so you've got to understand that, and then it's going to impact. But yeah, are we ready for the change? It's going to come. So the best is to be ready with an open mind and embrace it, and be ready for the change as it comes.
Yep. So we need to have an umbrella before it rains.
Or ready, I would say enjoy the rain. I would say don't worry about the umbrella.
Oh yeah,
enjoy
I
the
like
rain.
that one better actually. Enjoy the rain, yeah.
Yeah.
Okay, we have a couple more questions. So it's from Tri Destanto from Universitas Mitra. So the question is there any special requirements in building a virtual world in the NVIDIA Omniverse?
That's a very good question. Extremely good. There is no special requirement. The fundamental thing is, what do we have? Where do we go? What kind of information do I have? Because digital twin is extremely, for me, it is a living model, right? it churns out data. Okay, I get a model, I feed in data, it behaves certain way, it gives me that information, and I use that information, I feed it into the real world, and I get some more data, I feed it into the virtual world. This is a whole cycle, and that is what is a digital twin in the shortest form. So to create this, so yeah, you have to start somewhere. So where you need to assess, what do I have and what am I going to create, what do I need. So if you are able to create or understand this, where you are and where you want to go, then you can formulate these steps. And there is no right or wrong, because you can't get from here to here in one shot, because it's got to be small steps. Nobody's ever nobody can ever have this single shot jump down there. There is nothing a silver bullet down. So in any big problem, right, you just got to take small steps, and then step by step. So if you want to build I don't know, we call it as a smart city or a virtual capital, right, the Nusantara, as we say. Is it possible to build? Yes, it's possible. Can you do it for us? No, I cannot do it. Why? Because I don't know. But again, I've seen people who are doing it, and then whatever, it takes time. And is it perfect? No, they have not even achieved it. So there are people, you have to start somewhere. You got to understand the use cases and say, hey, if I'm looking at ensuring that I have good roads, how do I do that? So that is first your use case. You have identified that use case. So what do we need for that? So you take this data and you create a step-by-step model, and that is how you would start.
I would agree. So we need to have a list of requirements, what we want to
use
do.
Cases.
Then,
yes.
Yeah.
What do I want to do with the use case, and then get started. I mean, with the digital twin, what do I want from the digital twin? Once you have that, you can understand what you would need to get all of those answers.
Mm-hmm. Sounds good. So we have two more questions, actually. So the question is, will Omniverse compile our new algorithm or physics formula automatically run parallel on CUDA or NVIDIA?
No. Omniverse does not do anything. You have to do everything. Omniverse is just a platform for collaboration. Now, what it can do is it can help you collaborate. Say you and somebody else is developing something, so it can help you bring those. Or if you, for example, bring these two researchers together, or for that matter, you are running this algorithm and you're creating tons of data and you want to visualize it using all of this, the RTX technology in real time, and you want to keep changing some parameters, say wind direction or temperature, or for that matter, a composition of something. And because typically if you have this huge amount of data and you want to change this, even results, it takes a long time to compute. But with RTX, what's going to happen is this is going to happen in real time. So that is in the fraction of seconds. So and that is what it can do. It will not do anything for you. You still have to do the most of the work, but it can perhaps aid in some sort of decision making for you.
Sounds good. So Omniverse is just a platform that helps to make everything happen.
Yes.
And
accelerates.
Yes, accelerate. Yep. So one last question is from Nielsen. So the question is, does the NVIDIA Omniverse application support all types of computers and labs?
Now, as I said, right, we don't discriminate between the hardware, but as long as you have the Ampere series or the high-end GPU. Why? Because visualization or realistic visualization with ray tracing and all of it is very compute intensive or graphics intensive, as we call it, right? So you will definitely need, okay, I'm going to be taking this away. So if you have not scanned it, you should look at scanning it. Just a moment. What I'm going to do is I'm going to flash that screen again of the GPUs. Give me a minute. Yep. So yeah, A40s, A6000s, A5000s, and A4000. I wouldn't say everyone going for A2000. A2000 is only when you are creating smaller scenes, which very likely when you're doing digital twins is not the case. So yeah, anything to do with A4, 5, and 6 are at least a decent size. And then you sometimes, depending on what you're doing, you would need multiple of these actually. 2, 3, 4, because yeah, some of these scenes, when you're talking about huge gigabytes of data to visualize, yeah, I mean, not even a single 48 gigs GPU would do. You would need 3, 4 of these to simultaneously do it. But again, yeah, it depends on the use case, as I said. But this will be your starting point. Doesn't matter who the OEM is. Yeah, if you have any of these cards, you're good to go.
Sounds good. So this is the important part, like we need to have that RTX.
Yeah, the basic building blocks. So yeah, without the basics or the foundation, right, you cannot start somewhere. So the foundation for all of this is going to be the foundation for all of this is going to be these RTX GPUs. I mean the A series, Ampere series.
Thank you. Actually, we have one more question. It just came in. Yeah. So is Omniverse, can it be connected to other metaverse like Decentraland or other alike?
Not yet. Decentraland, or for that matter, what's the other one? It's all for fun, right? It's fun. There is nothing no value. I mean, when I say value, there is no engineering job that's being done there. Yeah, it's good to have, and then you buy these plots of land and all of it. It's good to be there. I can spend time, but I mean, it's not yet available because the purpose of Omniverse is different. We are trying to solve some engineering problems here. And then, of course, down the line, it will not be this year, next year, I don't know when, 5 years, I don't know, 10 years, I don't know. But eventually, these all will be connected, interportability. That is from Omniverse, because Omniverse is, that's where we are saying, right? Doesn't matter which world you're in, engineering world to a gaming world to wherever you are. And then we are creating the foundation called as USD for all of this. And you can just port in and port out. And that is the vision that I have, or that I foresee what a typical multi-virtual worlds will look like, multiverse as we can call it. Not a metaverse, but a multiverse, because all of these are different universes. I mean, Decentraland is different. Yeah, I mean, there would be thousands like those. And then you have all your video games. All of these are different worlds. But yeah, there will be this common denominator of everything being in USD format, where you can just put in. So I can just take my assets from Decentraland and move into Fortnite. And from there, I can come into Omniverse and so on. So there would be, but yeah, not right now.
Yeah, that will be interesting to see when it actually happens, yeah, which we don't know when, but it's coming maybe.
Yeah, it's coming. It'll come. Yeah, because metaverse or multiverse, as we call it, it will happen. But yeah, I just don't know when, because the pieces are there. I think it takes time to build all of it and then have the common platform there. Yes.
Sounds good. So I think that's all the questions that we have for today's webinar. So thank you, Raghu, for the presentation. It's a lot of information, really interesting. Then it's a lot that we need to learn more, like a lot, because a lot can be done with NVIDIA Omniverse for sure. And then also thank you for the questions that coming in the Q&A and then on the chat. And then thank you. It's a really interactive chat, as we can see. Also thank you for Pak Surya that has been helping answering some questions and then offering some insights.
Thank you.
And then, so as Bu Anggi mentioned before the session, before the Q&A session, so we have selected 5 best questions. And then in Epsindo, we'll send a little present as an appreciation. And then I think here we go. So we have 5 questions. The first one is for Alim Misbula from Universitas Syah, and then Fitra Putri Oganda from University of Raharja, and then Pras Nurzaki Anki from Universitas Indonesia, Nur Udin from Universitas Pembangunan Jaya, and then the last one is for Tri Destanto from Universitas Mitra. So for those people, please, I think we can send an email to ali@epsindo.com and then .co.id, epsindo.co.id, and then I will go from there. So I think that's all that we have for the webinar and Q&A session. So saya kembali ke Bu Anggi. Terima kasih.
Baik, terima kasih Bu Lina Wirahadi. Thank you very much for the good presentation, Mr. Ragu Ganti. Dan juga terima kasih banyak kepada Ibu Lina Wirahadi yang telah membantu memoderatori sesi webinar siang hari ini. Dan terima kasih juga kepada seluruh hadirin yang telah bergabung dalam webinar siang ini. Tadi seperti sudah disampaikan Bu Lina bahwa ada 5 nama, mungkin saya ulangi kembali. Untuk yang pertama Bapak Ali Misbullah dari Universitas Syekh Kuala. Kemudian yang kedua ada Ibu Fitra Putri Oganda dari Universitas Raharja. Kemudian yang ketiga ada Bapak Pras Nurzaki Anki dari Universitas Indonesia. Kemudian yang keempat ada Pak Nur Udin dari Universitas Pembangunan Jaya. Dan yang kelima ada Bapak Tri Destanto dari Universitas Mitra Indonesia. Bagi 5 nama yang telah saya sebutkan tadi, silakan mengirimkan identitas untuk pengiriman hadiah melalui email ali@epsindo.co.id. Saya ulangi lagi, nanti bisa mengirimkan email melalui ali@epsindo.co.id. Baik hadirin, sampailah kita pada sesi terakhir. Kami berharap kerjasama ini dapat meningkatkan kemampuan AI kita dan tentunya memberikan nilai tambah yang besar bagi daya saing negara kita. Nah, nantikan informasi seputar AI lainnya pada webinar-webinar selanjutnya. Jaga kesehatan dan patuhi protokol kesehatan. Sampai jumpa di webinar selanjutnya. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih Ibu Lina, Mr. Ragu, dan juga Bapak Ibu hadirin sekalian. Sampai bertemu di sesi selanjutnya.
Memasuki industri 4.0, kehidupan kita saat ini tidak dapat dipisahkan dari teknologi dan sistem artificial intelligence, atau yang lebih kita kenal dengan AI. Artificial intelligence atau kecerdasan artifisial adalah sebuah sistem di mana kecerdasan yang dimiliki manusia dimodelkan di dalam mesin dan diprogram agar dapat berpikir sama seperti manusia.
Siapa yang menguasai AI, dia yang akan berpotensi menguasai dunia.
Dikti AI Center hadir dengan superkomputer berkemampuan komputasi 25 petaflops, dapat dimanfaatkan oleh seluruh sivitas akademika perguruan tinggi dan mitra industrinya. Selain fasilitas teknologi, Dikti AI Center juga akan menyelenggarakan pelatihan, pendampingan, webinar, serta hackathon. Untuk itu, bagi seluruh perguruan tinggi di Indonesia, mari bersama-sama memaksimalkan serta memanfaatkan Dikti AI Center untuk menciptakan ekosistem penelitian dan inovasi kecerdasan artifisial di perguruan tinggi.